All right, cool. Hi, everybody. Vigne, Yuchi, Sweeto, Gichun, Shuik. Everybody, Akash, Siddhi, James. Hello. Shamsuddin, Kevin, Nathan. My character wanted to say hello. Character wanted to say hello. Exactly, last class, can you believe it? Minus Yuji, Akil, V1, Vignesh, Karishma, Jackly, Fang, Tianchen, everybody. Wow, cool. And one more character. Two of them. It's not finished yet. Like, yeah. They're all saying hi. Exactly. Last but not least, that is absolutely the way to look at it. I like it.
Hi,
On that note,
Professor.
I'm going to say stop video for now. Hi, Karthik. You guys can stay
Professor,
on.
I have a question.
Yeah, yeah, go for it.
What's the difference between what's the 561, 567, or any other related courses
Yeah, this one.
to yeah.
Well, our course, right, is really supposed to, be about data, which is I think how I try to keep it. Whereas other courses that are actually machine learning, data science related, might get, yeah, exactly, they might get more focused on ML itself, where they might be more about the algorithms, more about the math, more about the equations, and less about how you actually take a folder full of images and train them using a Keras network. Meaning they might be more theoretical. In fact, I shouldn't say they might be. They actually are more theoretical, than like a course like 561. Is because 567 is geared towards people that actually want to continue on after masters and do a PhD, which until the web came along is really what most people did. When you went to masters, you almost certainly went on to do a PhD. So our courses still reflect that they never changed. Whereas industry says, you can stop after masters and get like a 180K, per year job. And many students do that. So we have not updated our courses like 567. That's the answer. Yeah. So it's interesting. Jenny says, I had a tough time. Right. I'll just tell you bluntly, it is not a bad course or anything. I'm not slamming it at all. It's my own CS department, my colleagues, right? But like I said, the focus is so different because it is for people that want to extend the field. I showed you so many GANs the other day. So where does the next generation of GAN come from? Or beyond GAN and VAE, what is out there? Stuff like that. So it is for people that extend the field. Whereas 561 and the second half of 585 were like extremely practical. We're just saying, in fact, now you realize a database can be as simple as a G Drive folder. So it doesn't have to be Oracle, right? And then likewise from Mongo, you realize I just go to a shell and start typing some JSON, and then it calls it a document, and that's one row of data. It is that simple. So that is the deal. Yeah, advanced data stores you can ask around. That's an interesting course as well. It talks about specialized databases. It's really what it is. It might be like a follow-on, to this class. Even things like search engines, there's a course on that as well, like information retrieval. Yeah, there's many things, many ways you can branch off, I think, from 585. So those are all some of them. Interesting how to develop your own DB. Yeah. So if you go on Wikipedia, you can actually see like a whole mass of like NoSQL databases and a whole mass of relational databases. So it is good to learn to write them. I'm going to share my screen pretty soon. So the Windows update absolutely did like a horrible number on my JackDB. So on my machine, and apparently like thousands of machines all over the world, I tried to undo it. Actually went all the way back. It took me 5 hours and I got two blue screens of death, but it still never went all the way back. It leaves pixel residue on my screen. Oh my God, it's happening. Wait, so my screen completely flashes and goes black. So it happened one time. I'm hoping it'll only happen 4 times. If it happens more than 4 times, this is like number two. I might have to go away and come back, okay? It's related to the update. I'm only sharing the browser just so you know, but my screen flashed entirely. It all goes black. It's stable now. Don't move. Don't talk. Wow. Okay. So two weird flash. No, it's the third one. Oh, no, 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 no. Okay. A third complete flash. What I mean by a flash is a blank, like the whole screen just disappears. Okay, let's see if it does it again. It's very weird. Okay, it's all related to graphics drivers and the Windows update. I got a new NVIDIA driver as well. So maybe that's the problem. I have a new driver. So it flashed the fourth time. I'm hoping it's not going to keep doing it. It's a big waste of time because we lose about 5 minutes, right? Let me go back. Okay. So I can see the chat. Hopefully they're stable. Yeah, right. I mean, then basically, chooses like, a software that they support. So we do use Zoom. Maybe that can change in the future. I don't know. Last spring I used WebEx, it was very different. But then last fall, and then, now we're using Spring. Okay. It seems to be okay. So let's just keep our fingers crossed. It's going to be okay. Yeah, 4 flashes, like random flashes. Cool. So I have neat things to tell you, as always. So let's start with this. Neural networks for babies. Hey, start them pretty young, right? They still can't even walk, but they know exactly what classification is. Bing! It's a red star. So surprisingly, the neural networks in the baby's brain register the words red star. There you go. And this here, take a bunch of lettuce, dress it up, put some little olives in there. If anyone sees a, let us know. Get it? Get it? Let us know. Exactly. So in the future, you need to pretty much start them when they're still in the crib, right? What I want to do for about an hour is this. We are going to go to ML tools. So this is the plan for today. I think it can happen because I have short lectures, but 3 of them. We will spend a little less than an hour because mostly it was about what you already know and you've done your homework. But I want to point out like lots and lots of cool tools. And then if we have time, I want to take you to extras because I put about 10 or more different extras, all machine learning based. I love machine learning, by the way, but I also think it's the biggest bogus fake thing in the world. See, I'm split brained. Okay, but it works. It's good. Then I want to talk for the next hour about data visualization. It's always a cool idea to visualize data. It's a human endeavor, meaning we don't deal that well with numbers and columns, tables, and so on. But you show me a picture, I instantly get it. COVID, right? Spread of COVID, think about it. Graphs, charts, pictures. So we need to do that with data. It's quite useful. It's also an art form. It's not just science, it's science and art, it's visual. And then I want to talk about things like privacy of your data, and then, about data security. And there's very important concepts like data ethics, because the reason is machine learning is, I told you, 100% blind, dumb, really. It just looks for patterns. But people are actually trusting it with basically life-changing decisions, such as, do you actually get continued medical coverage for your insulin or not? So if the AI says no more money for your insulin anymore, the family would have to probably let a patient die, stuff like that, okay? Or a machine gun that is mounted on a helicopter, and then it has so-called AI camera looking for enemies, but except it shoots a friendly soldier dead instantly. Scary, right? So these are like big deals because, people don't understand that it's actually pretty dumb, but then they turn it live on like real societies. So then I want to talk about that because it's a big deal. That is why in Google, actually 2 people got fired because they spoke up against like how Google does not do it right. So Google's response was to say, you're complaining too much. All right. Yes, exactly. Just no, don't use. That's correct. Our brain is not blind. The word experience is a big, 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 big deal. The word experience needs a body. Okay, remember that. Yeah. There's no experience in data. If you collect like a ton of data, it is data, it is columns, it's a pattern, but no experience. Experience is physical. The mental experience, in fact, relates to a physical experience. So let's not go through machine learning. So I talked about all this, right? But let's do DMML tools today, okay? Because we're fully caught up with all the other stuff, really. Okay, so the last lecture was all about this idea of what is called supervised machine learning, which is you take a pile of data and then you train a neural network with a specific architecture over and over and over and over again. And all that training means is you make it calculate proper weights, which is like what you do in your homework, actually. So once the weights are properly calculated, the error is as little as possible, reasonable. And then you stop training it because, that's as good as you're going to get. Then the idea would be if you feed it some brand new data, which is pretty similar to the data you already trained it on, then it's going to use the past pattern, all the weights calculation, and do the linear summation, multiplication, adding, and then apply the sigmoid. And finally, at the very end, you're going to get a classification, okay, a multi-way classification. It's called softmax, but it just simply means I can now classify into A, B, C, D, E, F, how many error classes you want. You turn all the classification final numbers that you get from the sigmoid into like a probability array. Or if you add all the probabilities, they add up to 1, then that turns into like a confidence that you have in the estimate, meaning it might say 70% dog, 30% cat, or 70% dog, 20% cat, 10% bird. Then you go with the 70, you go with the larger number. So the last step is pretty simple, softmax. In any case, that is the overall idea. It's a really simple idea. Then the question would be, what kind of tools are out there? In your own homework, I didn't tell you start from scratch and write everything in Python, because that is crazy. Okay, absolutely nobody does that. You'll be doing it all, for many months and you still wouldn't get it right. So we thankfully have so many tools. So that is what I want to focus on. Yeah, right, exactly. So on purpose, I put that in just to say the network is sometimes not easily foolable. And so, it does a pretty good job of learning. Eventually you get it to work. But if you know what kind of cats or what kind of dogs look for, that helps as well. Like certain dogs might look like a cat. Like think of the Akita, for example, right? Or Huskies. They have straight ears that a lot of times look like cat ears. So some dogs look like cats and some cats look like dogs. So now I'm going to show you tools, frameworks. So a tool is basically like a program that you run from scratch. A framework might be a bunch of libraries, modules. An API is just a single set of functions. Framework would do many things, and API would do just one set of things. Or you have just a raw programming language. And then, what kind of hardware helps with all of this. So this is exactly what we do in industry. So if you join Amazon, Google, Apple, Gmafia, BAT, anybody, they all use these APIs. I'm going to tell you basically what the industry does. In other words, just a core course like 567 is not going to be enough at all, because I'll ask you, what API do you know? So the idea is not to spend like hours and hours on these. Mostly I'm going to name them, okay? But you can look them up, because all of this has been said in other ways before. TensorFlow, which we already talked about, is Google's offering. It was a Python library, but now it's also a JavaScript library, and then pretty soon in other languages. So it's ultimately just a graph data flow library. So you feed like data through it through every node, and the node calculates something, sends data down to other nodes that are connected to it. And here the idea would be you would use that node idea, the node philosophy, to build neural networks, because every neuron becomes a node. Every neuron in a column, they all node, and then more node downstream, and nodes can be wired. That's what data flow does. So if the whole neural network is a big data flow graph, you feed input to it, the data flow magically will then make data come out the other side. That is called TensorFlow. Yeah, correct. It always helps to know more like how it works, but many people actually don't, though. They just blindly follow the tutorial. It helps. Correct. I definitely agree with that. So TensorFlow is pretty cool, but now Google has a hardware version of it. It's called TPU, Tensor Processing Unit. So that is what they actually put in their course. And if you ask me what is a tensor, it's not a physics tensor. In physics, you have things like stress tensors, okay? But this is much simpler. A tensor is just simply a multidimensional array. It's an array of an array of an array, or a multidimensional matrix, however you want to look at it. So a scalar, a vector is just linear, and a matrix is two-dimensional. What if you want a bunch of matrices? The reason why this is because they look like neuron columns, okay? Yeah, that came later on. So what happened was, the story is this. Initially, there was no such thing as a TPU. Google invents this, right? And NVIDIA still makes the best GPUs in the world. So for a while, yeah, tensor is an array of matrices, but you can even have an array of tensors. Like you can have an array of these as well. So it's basically a multidimensional list is how I'm going to answer, Kevin. Here it looks like an array of matrices, but it's not limited to matrices or arrays, okay? Think of them as Python lists or C++. No, multidimensional arrays is what it is. So just roughly, this is a joke. Okay, so the GPU idea. Initially, Google paid NVIDIA a lot of money for buying the NVIDIA GPUs and putting them in their self-driving cars. After a while, Google realized we don't need to do that because NVIDIA does graphics GPUs. We should do a more machine learning oriented GPU, which is what a TPU is, a tensor processing unit. Like I said, Waymo self-driving car has these because all this has happened in real time. Then NVIDIA said, wow, this whole tensor processing is a good idea. So we should add a tensor support into our GPUs. So now the latest NVIDIA GPUs do have tensors. So it came back to them in a way, okay? But still Google does not buy it. Other companies could buy it if they want to do tensor processing, but not buy TPUs. Spark, which I named earlier, that's one of the streaming data platforms. If you want to do streaming data and also do machine learning on it, then you have this mlib that you can download. And so that's a module. And then you can use this on a cluster to train like a neural network in parallel. Okay. So then that's what this is. You can go look at all this. Keras is exactly what I gave you for the homework. And this is one of the Python libraries that makes neural network creation so simple. Okay. The other competing API is called PyTorch. So in here, all of these, you can go read this afterwards. I give you like a whole book on it. But every architecture that's already out in the world, things like ImageLet, LeNet, any kind of net, right? All already come with Keras, meaning the code has been written. So you simply have to just instantiate it. And all the types of layers that are possible, for example, ReLU, and then Maxpool, all of that are already just library calls. So in just like 10, 20, 30 lines, you can make a whole network and start training it. So that is the magic of Keras, okay? And Keras underneath is actually using TensorFlow calls, believe it or not. So it's actually a higher level layer on top of TensorFlow. You could write the whole homework, by the way, code by yourself using TensorFlow. It'll be much longer than the notebook that I gave you. So Keras compresses it, just makes it easy, okay? So then starts right there like that. It's a higher level library. And then all the layers, I told you there's many kinds of layers, which are all the processing that happens in every one of them. So I give you like an infographic, okay? You can just click on it. You see it goes like this. For example, reshape layer, that's one of them. And then you have the dropout layer, which like randomly sets things to 0. And then flatten layer, dense layer, all these different layers. So for the homework, the code that I gave you uses some of these layers, okay? So you can later on go and make the comparisons. Cool. But Keras is ultimately like a library that you program in. Torch, which actually is written in Lua. It's a programming language called Lua, was what Torch was written in. But then it's not used in Lua form too much because Facebook took it. Lian Luken, the CNN pioneer, convolution network pioneer, he loved Torch. So he made a PyTorch port. So Facebook heavily uses PyTorch. Therefore, if you want to learn Torch, then learn PyTorch. Don't even learn the actual Torch at all. It's not worth it. So Facebook heavily uses PyTorch. Yan still writes code using PyTorch and does like, CNN experiments. You could have done the homework, with this as well. It's just like an alternate layer, okay? The alternate implementation. I see, interesting. Yeah, exactly. So Microsoft and Lua, they all go together. Microsoft loves Lua. If you want to write Xbox games, you can actually do them in Lua. Scikit-learn is yet another machine learning library. These are all machine learning libraries, you guys, okay? So like that. And every one of them ultimately is going to do the same thing. You can take the same data set, and then the code is just going to look different. That's all. The syntax looks different, but not even much more or much less, just different. For example, you want to do k-means. We just talked about k-means. You can take all this, by the way, and just simply plop them into one of the notebooks in Colab and instantly start training. Now that you know Colab, you can actually play with all of these, all right? So at some point after this course, just do it. Yeah, because C# is an actual full Java-like language, and then Lua is a scripting language, much simpler, lightweight. I agree with that. Cool. Theano, which is not used too much, I shouldn't even talk about it, but it's out there. It's actually a cool library. It fell out of favor, but that's yet another machine learning library. So Theano, Scikit-learn, MXNet, Keras, PyTorch are all similar. And the top two are actually PyTorch or Keras. People just like A or B. Caffe is also another one, which is now called Caffe 2. It came from Berkeley initially. Is yet another machine learning library. All of these are higher level than TensorFlow. Oops, never mind. Okay, so that we cannot reach. But see like that, okay? Interesting. So Caffe actually went to PyTorch. Good to know. We don't need too many, by the way. It's almost like a Cambrian explosion, meaning in nature, evolution-wise, so many things happen, and then some of them die off. It's the same idea. They all invent too much, okay? But the initial Caffe might be around because Berkeley has a machine learning group. They probably still support it. These are all just FYIs, okay? Okay, so you see, like, read the tutorial installation, Model Zoo. Model Zoo would be full of all kinds of networks. They're already trained like that. See CaffeNet, AlexNet, GoogleNet. So if you see any one of these, you can even go to it all still works, by the way. Just because it is version 1, there's nothing wrong with it. So you can do this and probably it'll work. Cool. I'm just naming your library after library. This is very cool. Apache, after all, the open source biggest organization in the world. They make MXNet. So that has APIs in every single language you can imagine. C++, Java, Rust, Python. So that is the nice thing about MXNet. So you see a tutorial in Python, you can probably do it in JavaScript as well, okay? So that's a pretty cool library. Again, they all do the exact same thing. It's all data-driven, okay? And then finally, Microsoft said, we can do this too. So it's called Cognitive Toolkit. The word cognitive is a very bad word because cognitive actually means you're doing something with your brain, you're thinking, except there's no thought in any of these, including CNTK. IBM, also in the Watson Toolkit, for a while they used to call it the Watson Cognitive Toolkit. People called them on it and said, you're lying to people because there's no brain. And then they walked it back. They just call it now the Watson API. But Microsoft's, C stuck, but we still call it CNTK. In any case, it's zero cognition, okay? When a neural network actually thinks, it thinks about what happened last night, then we have every reason to be pretty excited, probably pretty scared. then AI could become real. But right now, there's no thought. Okay, thinking is a big deal that people do. All right. Meanwhile, you can run all the tutorials. See, it's in Python and C Sharp. Again, you see, it's all the same things over and over. MNIST, by the way, is just a handwritten digit database. What if you take a whole bunch of 1 written by different people, 2 by different people, 3 and what, and then you train a network, and then you write one in your handwriting, it'll properly classify that to be one. It's basically a classic data set that we all use to evaluate how well our models do. Okay, so there was an MNIST tutorial. Good. More frameworks. So Huawei has something called MindSpore, and this is actually very cool, so because they want to go against TensorFlow and PyTorch. Very cool, right? So if you want, you can just try that. Just go to the page. I won't do much more than that. Oh, never mind. Sorry, I said that. This is very interesting, cool, because Facebook said this whole data flow, which I've talked about a lot in this class. I love data flow. I think it's an amazing architecture. Facebook said we should also do data flow. It is called FB Learner, okay? It's a very similar idea, but it's not Google's tensors at all, okay? But it's the same deal. You make basically a graph, and then there's a graph runner. You tell the runner, run the graph like this. By runner, what I mean is you're not directly saying run and does it. Some other system is saying run this, and then after that is done, run this, and then run this in parallel, and then make this wait so that this can finish. In other words, after this is done, these two have to run, and then this input is already available, but these two have not run, so that is the wait. It's like a dependency, like your make file when you compile, okay? You set up a dependency, and then the graph runner will take care of it. Otherwise, it's the exact same idea. They can make a graph and run it in Facebook servers. Apache is very cool. They have something called Mahout. Mahout is a Hindi Sanskrit word for an elephant trainer. It's all about Hadoop, okay, because it's an elephant. So they called it Mahout. So Mahout is basically, it's very interesting machine learning algorithm. So you can run them in Java or Scala on Hadoop directly. Microsoft's .NET directly has machine learning implemented. So that's like a .NET layer. Yeah, exactly. That's correct. So this is a very good answer right there. And you say, why do you need one more? Why don't they just keep it in C# or Python? Because there are so many .NET serious application frameworks in banks and things like that. So if a bank wants to turn all their data into like a neural network they want to train it on, then they would probably use that, okay? F# is Microsoft's functional programming language we didn't know. So it's not the same as C#. C# is like basically a Java clone. You see, this is what banks would like to do, right? Fraud detection. Likewise, this is exactly what Amazon would like to do. This is what Amazon would like to do, and on and on. This is what maybe the FBI wants to do. So they can all like do, things just used based on these libraries. Okay, so fast AI is also nice because it's written purely using PyTorch. So it's at a higher level than PyTorch. The higher the level it is, the easier it is to program. But also at the same time, it might be difficult to actually have controls to all the lower level. Okay, you have to choose. You say, I just want to quickly get a network going. Well, then use FastAI. I want to go and tweak the hyperparameter. Well, then go to PyTorch. So you can dip into the lower level or the higher level, depending on what you want. But see, you can do like so many things. Just keep going. Okay, so that's FastAI. Yeah, definitely. I'll definitely do that for sure. Yeah. And then OpenVINO is wonderful because now there's it's the Intel library. Okay, so Intel, as you know, is starting to make all these, computer vision hardware. So then that is their library, OpenVINO. So once you have OpenVINO, you're able to like run it on all these machines, all these operating systems, and then that's what it does. Okay, so just name them, just name. Turi, okay, I haven't told you about Apple's CreateML, so let me quickly tell you. Once you do your homework, for example, right, exactly like you did your homework, your network is actually trained to classify cats and dogs. So therefore, what if you could then somehow in some portable architecture, export the network and the weights, and you send it to somebody halfway across the world. They can instantly just use a few lines and then get the network back with the weights and start feeding dogs, like the second half of your homework. Your homework was basically in two parts. The first part, you simply ran the code that I gave you, and then it went through all the epochs and it trained it. Then the second half, you brought it back again, you read the weights file. That's what this is. So what if the weights file was not .h file? What if it's in a more portable format, okay? Then that is called CreateML. Yeah, I was going to actually tell you about that, believe it or not. Yes, exactly. Very nice. That's so smart. So yeah, Tencent has a very similar deal, right? There's a few alternatives to CreateML. But in the Apple's universe, it is called CreateML, okay? So you use the CreateML API and then export the data, export the architecture as an Apple format. Then any iPhone app can quickly read that network. and then your phone can start to classify something. Okay, so because Apple created that, the open source community basically said we want something alternative. It is called Turi. The Turi is very similar to the Create ML that Apple had. Okay, but now what I'm telling you is a very cool idea, which is how do you actually take a network and export it so that somebody can very easily read that backend. Yeah, right, exactly. So OpenGL, right, runs in GPU. Say you want to do style transfer, which is take your CAD and make it be all these things. The architecture is already done. So in the easiest possible few lines, how do you load that architecture into your, or rather, how do you load that into your application? Then you would use something like a Turi file format, small laser file format. There's also one more called the Onyx. Okay, so Onyx is ONNX. So Onyx is also a machine learning architecture format where you can take so many trained layers and then export them all using this Onyx format. This way there can be many writers and many readers, meaning I can train something on AWS and you can load that back into Baidu or something, right? I see, cool. Yeah, so there's Onyx, there's Turi, there's Create ML, and then there's also NCNN, okay, from Tencent. Very cool that you brought that up, thank you. So these are all efforts on the part of people to say, wow, this is now so mature that we should start exchanging data with each other, meaning these layers with each other. LibSVM, I talked about SVM. So this is very specific just to SVM. If you go to Kaggle data science competitions and you look at what architectures win new prizes, you will be surprised that it's not always neural networks. In fact, almost every single time it's not a neural network. It is something much simpler, something more specialized than that. LibSVM actually is one of them, okay? This library just does nothing but SVM. But sometimes for your data, that's all you need, okay? I don't know if this is all going to work or not, but we can try it. Okay, so you see, like that. So this is the command line, you get the library and you run it. And then you can read the paper about it. So a very dedicated library just for doing SVM, okay? So this is gradient boosted machines. So these are all like taking a decision tree, and then the decision tree is already done, right? So all the splits are all already determined. But what if you pass a bunch of data through it and then evaluate the efficiency of the tree, and then use the data's error metrics to go back and rebalance the tree and then re-split, meaning you're making the tree better and better. It's a lot like neural network training, but they're not neurons, they're not layers, they're actually a decision tree. That is called gradient boosting, okay? You use the gradient of the error to actually boost the accuracy. So then this is a library exactly to do that, like GBM. GBM, by the way, is one of those things that actually wins Keras competitions, okay? So interesting. Go read that, okay? So this is a good library to know if you want to compete for money someday. Cool. So then there's that. And XGBoost is yet another one, very similar. This also wins Kaggle competitions. I might even tell you that. Why not? Okay. So like that, multiple languages, yeah, battle tested. See, that's very interesting, right? That they can actually tell you that, not everybody can claim that. Yeah, correct. Yeah, this, as you know, boosting this bagging, right? So I went through that last time. So XGBoost is yet another library. So these are all libraries that do very specific things. Show you one more. Cool. So XGBoost. When you have time, if I were you, this is what I would do. I would actually go and try them and actually do them, get experience. Okay. CatBoost. This is a very cool company, Yandex. It's a Russian company. Ukraine. So look at that. CatBoost. It's a very similar idea, okay? Okay, so I might play this just for a minute. I'm Facebook friends with the founder.
Machine learning is a wide range of algorithms that learn from data to make better decisions and predictions. It is used in all kinds of tasks, from music and shopping.
Yeah, I thought they have offices in like places like Ukraine, but they might be in Moscow as well.
We have developed an open source and new machine learning tool that provides top accuracy for the most common business cases for machine learning. The tool is called CatBoost.
I'm not pretty soon it's going to show up.
A machine learning technique.
It
works great if you have
that's her.
From different sources.
So I talk to her once in a while. It's pretty funny. Like what they're up to. They have their own self-driving car, by the way. It's very interesting.
And data from weather stations.
They have big plans.
It's complementary to deep learning and is generally easier to use. While deep learning methods work very well for homogeneous data, especially sensor data.
So what they're saying is all right, because depending on the data, maybe that's the network. But for other things, trees are fine.
Many diverse data.
And use both.
Gradient boosting also works well when there is not much training data, whereas deep learning requires lots of data. The two play well together, however. Gradient boosting can easily integrate deep learning models and combine its outputs with other signals. One of our tutorials shows how TensorFlow trained deep learning-based text representations can be used as input into CatBoost. At Yandex, we use
That's very neat, okay? So you do deep learning and then use it to actually redo the tree. It's pretty smart.
Most machine learning tools work only with numerical data like height, weight, temperature, and so on. They do not support non-numerical features like color, red, white, or blue, or CG.
I'm not able to say things like non-numerical features, and I'm not able to say CatBoost. Make fun of her. She's my friend. Okay. You don't mind?
To convert those to numbers.
Okay, so I'm going to keep going. It's very cool. Okay, so you guys should like look at CatBoost. It's a very good product, and they have more things. Just go to Yandex. All right. So then you have this notion of massively scaling reinforcement. So this is like crazy. Okay. By the way, what they showed at Yandex is also deep reinforcement learning. So it's a combination of deep learning and reinforcement learning. So deep RL is a thing. So this is also a combination of deep learning and decision trees. So it is good to combine them, okay, in some ways. That's what this is. Okay, so then there's something called seed RL that I want you to send. That's what this is. Select that, okay? Again, same idea. All these are things that I want you to go back later on and look at it. This, by the way, does not use actually data. So maybe it's not exactly data related. Okay. Reinforcement learning is the only machine learning architecture where you don't need data, okay? Other things you do need data. Semi-supervised, definitely supervised. Okay, so then what if you want to distribute ML training exactly like you could do with the previous library that I showed you, with like SparkLib, right? SparkMLib. Then Uber actually has something called Fiber. That's what this is. So then let me go here. Oops, not the cloud. Sorry, just a few more here. Okay, so this is also a very cool idea. You can do distributed training. That way you can get it trained faster. Remember, they have a self-driving car, right? So that means you want to train it as fast as possible. Okay. This is a very interesting story between Uber and Google. I just want to quickly tell you. So one of the engineers from Google from Waymo actually left, and then he joined Uber. So Google instantly sued Uber. And the reason is this: as you know, your .h5 file, right, is gold. Because once you have an architecture, it's all about that weights file. The self-driving car is the exact same thing. You have an architecture that drives the car, and then the weights that go in it is what takes weeks, if not months, with proper good traffic data to train. So if somebody walks away with that file on a flash drive, so to speak, the very next day they can make a car be self-driving. That is what they accused the Uber engineer of doing. Okay, it's a very interesting lawsuit. Go read about it. Okay, so then you can read about Fiber here. Okay, so Fiber is actually very cool. Again, you see there's a master and there's all these workers. So it reminds you of Hadoop. It's the same idea. It's basically distributed processing. Okay, so you can do distributed training this way. It's a cool idea. Okay, so moving on. Yeah, then this is all very interesting, right? So for example, awesome prediction. This lists like a whole bunch of things I'm going to show you. Okay, like here, see that? So it's a massive catalog of many, many, many efforts. Okay, so many libraries. Look at this. So if you want more machine learning libraries to see your head, like, oh my God, I had no idea all this was up there. So many things. Obviously, some written on top of other things such as Python, TensorFlow, but still, every single one of them will take you to a custom link. Okay, now look at that. So if you don't want to use all the things I showed you, you can use probably D6T flow. Wow. Okay. So this, I want to go through all this. Just want to show you that this is also out there. Just crazy. Yeah. Crazy meaning cool. You have so many choices, and you can get the source for it. Remember, it's on GitHub. And then, what tools are on the cloud? So cloud offers two things. Remember, for all practical purposes, you have infinite computing power. Just pay for it. And then likewise, you can store anything the heck you want. These training data, right? They're not like small at all, as you know. Yours was relatively small, only 500 images of cats and dogs. What if you had 5 million images, of many, many kinds of cats and dogs? That's the next step. So obviously, things like Google, their networks do that. This is how, because they have the cloud they can use. So data heavy and computation heavy. So Amazon has, to start with, this page. I won't again tell you too much, tell you the basics. They have two levels of this. So every vendor, Amazon, Microsoft, and Google, they have two levels of what they offer. One is they give you just the raw storage and computing, and then you can do everything yourself. You can upload your own, Python library, upload your own data and train it. Then that's how it all started. And then it occurred to them that other people that are not very technically savvy can use a higher level library, meaning they can do all the training themselves. For example, Amazon has something called the recognition engine, okay? It's called like a German K, recognition engine. So this recognition engine is basically Amazon's own API that they deploy on the cloud. So this way, the end users have to just supply a video, and recognition would go into every video frame and tag every single object in the video. It's crazy, right? So you can even go around your room, just take a little clip. It'll tell you everything in your room. That's all you have to do, upload your video. So it is incredibly powerful, but they obviously charged, the customers more for doing that. See that? Just upload the video. It'll tell you like what's in it. Okay, look, person 99% crest, outdoors it knows because of the clouds and everything. Mountain bike it knows about, rock it knows. Not bad, meaning it's pretty good. And then this is what the world uses it for. Somebody uploads a video to Facebook. Facebook has no idea what the hell is in it. Right now, they're human content moderators, but the job is so horrible because they see people being shot. Somebody uploads that, okay, or some baby being raped, okay, it's like horrible, evil, cruel stuff. So people quit. It's one of the worst jobs in the world. The dream is someday AI can fly it, but the AI is not ready at all. But things like recognition can gradually get us there, okay. They can even go in a video and look in every frame and identify text, okay, like what does the t-shirt say? And it's just insanely cool. It means you can go to any movie, any NFL game in the past and identify every single object, every player. Yeah. So these are all the big companies that are using it, right? Cool. Okay, so those APIs are at a high level. This is just the lowest level. Okay, I'll play like a few seconds.
AWS provides every developer and data scientist the broadest and deepest set of machine learning services on the most comprehensive cloud platform, enabling them to create impactful solutions faster. Developers can quickly add intelligence to applications without needing machine learning expertise, using pre-trained AI services to do things such as create more intelligent contact centers, improve demand forecasting,
I see.
detect fraud, personalized
Indeed.
consumer experience, and more. For machine learning practitioners,
Yeah, that's
and
funny.
data scientists who want to
Like stealing
build,
cycles,
train, and
right?
deploy models, Amazon SageMaker offers
The proper way to do this is the protein folding experiment, right? Because protein folding takes a lot of resources. Or the search for extraterrestrial intelligence city. You would volunteer your machine, knowingly, and then when you're not using it, they'll use it. But then unknowingly, they can install all kinds of, like spyware, right? But they're not stealing your credit card data. They're actually running some computation. Yeah, that's like sly. You can do it through JavaScript, for example.
Control and visibility into each step
Okay,
required as a
so then
managed
this is actually very cool, but it's lowest level, okay? And they give you like so many, and these are all the big customers that they have. It's all a big deal. I mean, the world uses it. There's no doubt at all. There's no vaporware in any of these, by the way. Okay, so then this is the higher level. So I'll just show you. They have the developer conference every year, and then you can just watch the videos where they tell you like what is all coming up, okay? It's super cool. Okay, SageMaker. Yeah, so SageMaker is basically, again, like, high level library where they can take your data and then run your data simultaneously through multiple data science machine learning libraries, meaning a decision tree, an SVM neural network, and then evaluate the accuracy of all of them and give you the very best model possible so that you don't have to try all these experiments yourself, okay? So they do it for you. That's called SageMaker. Okay, it's also called a data robot. So what I told you is called a data robot, where say you pick an architecture, suppose you pick a neural network. Now the next question is, what should the learning rate be? What should the momentum be? Or what should the architecture be? Okay, let me go off and spend more months on the experiments and I'll come back to you. But they do that too. So data robot would do that and give you the best architecture pruned and give you the best parameters for it. Basically, they're telling you just supply your data. You cannot do better than this architecture. So that is good. There should be a check on these companies. Yeah, it is true. There should also be a check on Bitcoin mining because it's also getting out of hand, right? It's related. True, I agree with you. So Google has Google Cloud, right? And then Colab that you are running for your own homework is just one example. They give you a free GPU. But if you actually pay, they can give you like many more GPU instances. So your Colab can run much, much, much faster. Okay, but look at all things you can already do, right? Like this, you can do text to speech, speech to text. You can do translation. You can do like, this is what I just told you. Fine tune your architecture, get the best architecture for your data set, and then do all these. See, like it's all here. They even have, if you look around, little toy browser interfaces, meaning you can drag and drop. In fact, you can drag and drop this, and then it'll actually tell you incorrectly that it's a dog. Okay, try it later on. It's pretty funny. If you save this and actually drag and drop this on the Google API, unfortunately, the Google API would call this a dog. Okay, it's actually embarrassing. But if you go in Photoshop and you color this purple, it's actually a purple cabbage, then you upload it. It'll correctly label that as purple cabbage. Okay, try it. It's funny. Yeah. So these networks are cool at the same time, but they're not that cool because they just go by pixels. Okay, they have no idea what a real dog is. All right. So these are the things that I've showed you. This I won't show it to you again. Yes. So Microsoft. Yeah, Azure was the last among the three to actually start doing this, but they're pretty big now. They're Microsoft after all. And so they call it Azure Machine Learning. It's the same idea. Okay, they have the exact same deal. just upload everything to that cloud, and then
Machine learning delivers the predictive
again, just a few
intelligence
minutes with
businesses
this.
need to stay competitive. Still, many companies struggle to adopt machine learning solutions when data scientists and data engineers face tedious tasks, slow training, and complex deployment. Azure Machine Learning removes those barriers, accelerating the machine learning lifecycle from end to end.
Cool.
Cloud to edge.
On the left, JSON went, and then on the right hand side, some visualization showed up. Okay, so you see, so you can do all this. So this is the whole AutoML. Okay, like in fact, what they're talking about right there is actually AutoML. Feature engineering, by the way, means you might feed it like 12 columns of data, but then they can come and tell you, that column right there is not doing anything, so we'll actually delete that. So what columns work best? That's feature engineering. And then hyperparameter is about things like momentum, learning rate. And then this is actually what algorithm, like maybe a decision tree is better than your network. Okay, that's AutoML. Okay. All right, so that's all available to anybody that wants to pay. Cool. Basically, for courses, you get free credits, right? But then, then you get used to it. You go to your employer at work and say, I need AutoML. It's like a drug dealer giving you free drug samples, okay? So they give you free tokens when you're taking classes. But no, I'm basically having fun with it, but it's true though. Look, in Azure, you can do like all this. You can have scikit-learn and start doing all the things that we went through in class, okay? If you look through all of this carefully, you will know at least some of what we're talking about in here through our course, because I made it a point to tell you. Same thing, okay? The tune parameters. Again, same thing, do feature engineering, sometimes combine them, do PCA, principal component analysis, and maybe reduce some columns, like basically project them onto other columns, and then find the best architecture, and then within the architecture, tune the models. Okay, so over and over, it'll all be the same thing, okay? Once it is done, the model is what works in the world, meaning you go and fill out a credit card application. It either says success or no, sorry. So then they deploy it live, okay? Okay, so then they give you like so many cool things you can do with ML. Moving on. Yeah, right. And so then if you say, what else is there to, what if you don't have AutoML? Then you need to manually do it, right? You can do what is called neural architecture search. And then you come up with, again, different architectures. Or if you come up with one architecture that's the best, then you can try to prune it. So again, we went through some of this, okay? In the end, what it comes down to is I have some data. So what is the very best architecture for it? ML or not ML? So if it is ML, then within ML, you start saying, how can I then make it as efficient as possible? Like how do I not waste processing? Then you start pruning. Like some of those connections don't need to exist, okay? Okay, so we went through pruning, I'll skip it. And then you can also do this. So what if you don't use like a backpropagation steps at all? I think I told you this last time. You can actually use like differential equation. You can go back to actual calculus and then do what are called neural ODEs, neural ordinary differential equations. And then they, give you better convergence. And so you can probably the archive paper, I think I brought that up. So these are like better ways of designing the neural networks themselves, meaning the whole idea of backpropagation that happens in steps. There are more crude steps compared to what you can do if you treat the whole system as a collective system of differential equations. You know what is weird? In 1987, I think I showed you a newsletter, we actually thought of the whole neural network as being made of differential equations, believe it or not, okay? In a way, this has come full circle, but now they're doing it differently, meaning we've seen this movie before. Okay, so in any case, this is actually what a classic network does, and this is what an ODE does. It's just a more accurate way to train. You might get more global minima for all your weights. Okay, cool. So then that was that, and then now I'm going to start telling you more. IBM Cloud. Okay, well you can just go there. Basically, the cloud is the same as that, and then they also have a big neural network, and then you can use it for things like language translation. These are smaller companies, especially these top three. So H2O is one of them. They want to compete with the top three, which is Azure, and then Amazon and Google. So H2O is one of them. They have the same idea. They're cheaper. You'll give your data to them, and then like that, come up. See, same things, right? Ultimately, you have different programming languages. You have all the algorithms, and then they can do AutoML for you, and you can distribute them in Hadoop, and then easily deploy it. You start to see the similarities over and over, and then they're all doing the exact same thing. Okay, cool. It means technically you could take your homework and then even get a free account. They'll all give you free accounts, a demo account, and then try it. It'll actually work. And then you can see which is easier, which is harder. They're all different. So look at how many things H2O supports, practically every single language. They also have, just like Jupyter, a Flow GUI, okay, where it's like a notebook environment. And so you can do your deployment like a notebook. And then BigML is another one. So again, start going to some of these. Okay, bigml.com. So very similar, right? So you start to see they can use for all these applications, look at all the algorithms. In the end, this is what you need to ask, what algorithms do you support? And so all the things we went through in class, they'll support it. And then same idea, so how do you export them using some custom format? Like maybe what I mean is like create ML or, Onyx or something, and then very easily give the customers the power to upload the data. Because companies in the world don't want to play with all this. They don't want to pay you $200,000 a year so you can write like 5 lines of code a day or something like that. They don't know what you're doing. They want to do it themselves. So gradually, that's where this is all going. They make it so easy for the end user that knows a little bit to just go and log in and upload like a CSV file even, and then it's just working for them. Floyd Hub is also another GPU-based deep learning platform. Because again, when you say deep learning, there's lots of layers. You need GPUs. So they have GPUs on the cloud. It can do stuff like this, by the way. It's actually super cool. In Hollywood, there are so many movies that are black and white. But using machine learning, they can teach it what skin looks like, what the tree looks like, what the cloud looks like, what. Then you can take an old car or an old person from a black and white movie and automatically colorize them. In Hollywood, there's a job, actually, it's called colorizing. You pay humans to do it, right? But those jobs are gone, okay? You can automate it. That's one of the things you can do on Floyd Hub. You can also upload images and have it do style transfer. You can turn your photograph into a painting. You see, again, they have GPUs. Okay, so it's a very similar platform, but different. And then Paperspace algorithm, I don't want to go to both of those. So Paperspace also has a GPU. And then it's very similar. Oops, just go to Paperspace. They have a GPU cloud. So the clouds are all turning into what are called GPU clouds. They pay NVIDIA a lot of money. That's NVIDIA DGX right there. Okay, that's what that is. And so then, they go to NVIDIA and buy all these DGX machines and install them. And then you log on and just simply upload the data, okay, like that. Okay. So AI is becoming like a commodity, okay? So it is not this thing you write in Python anymore from scratch, although obviously you still can do that, which is what you did. Here they have so many little command line things you can try afterwards, okay? They give you small interfaces where you can type commands for things like training. Okay, let's quickly look at it just for a minute. You'll see how simple TensorFlow is, okay? It's like adding in Python A equal to B plus C. So A, B, C are all tensors.
Welcome to
You
Gradient.
can even do that if you want.
This video is a brief introduction to Paperspace Gradient. Whether you're developing, training, or deploying models at scale, Gradient is a lightweight yet powerful environment for all of your machine learning work. We'll cover how to develop and train models, how to deploy them. Learning teams spend more time on tooling.
So very similar to your homework. There's Jupyter Network, inside Jupyter Notebook and a free GPU.
Gradient
Okay.
is here to fix.
And then Python has that. Just pick your library.
Custom environment. Launch
That's very cool, right? They already installed all of those. So you don't need to give them like a dependency requirements.txt or something. They already have
your
it.
notebook on a power. If you're looking for a good starting point.
And then this is very cool. They even give you so many, not pre-trained. There's so many architectures already. So you pick one and then just start uploading your data to it.
Showcase includes a collection of interactive model training on power
Okay.
approach to machine learning.
In other words, practically all that is missing is your data, which is exactly what you have. So it's a perfect match. Okay, Algorithmia, which I use a lot, is actually very cool. They have, in fact, let me go to demos just straight. They have the colorizing, they have the neural network, style transfer that you can try. Okay, try all these demos. Just upload something and then you can get it. Colorize photos. We don't have time. So when they said try the demo, for example, right? Do that. Okay. Oh, am I doing it right? I'm not sure. Oh wait, I think it's try the demo at the bottom. Okay, yeah. Let me try that. Yeah. Okay. Well, you can upload one, right? So maybe we should do that, right? So what if we actually this is not the best. Do you think we should use this? Let's try it. Okay, we'll just see what it does with this, okay? It's not ideal, but I'm just going to do it because now is the time. Because I want you to see how simple this is. So I'm grabbing it so you're not sharing the screen. I want to save my desktop, okay? I'm going to save a picture of my desktop. And I'm going to call the picture test.png. So hang on while I do it. And then we're going to drag and drop test.png onto that interface. I think it saved it. Okay, so yeah, I have test.png. So I'm going to bring the browser back. And then now I'm screen sharing. I'm going to upload test. Okay, open. Okay, so it's as simple as just saying adding style. So the GAN goes to work, and then it already picked the style, meaning there's different styles to pick from. So they're taking the simple image that I uploaded, then applying those paint strokes and those colors and the texture. It minimizes what is called loss, right? Because all networks do that. You minimize a sum of what is called content loss and style loss. Content loss means you don't want your picture to come out like some other picture. You want to keep as much as possible your content. You want to minimize the loss. Style loss means whatever style they promised, they want to give it to you. They don't want to give you a different style. That's called minimizing style loss. So it's a combination of content loss and style loss minimizing. And then, by the way, you can do this yourself. I told you, right? So you can actually try this, make a little, JSON like that, and just upload it. You'll actually get the result. That's much longer than, wow, it's surprising. I'll probably do a few more seconds and we'll give up, okay? Normally, it's much, much faster than this. My image is tiny, by the way. My image is only like 512 by 512. Wow. Odd. Maybe it depends on like the machine load or something, don't know. Or they dropped this down to a pretty cheap GPU, or maybe no GPU at all. It's horrible. If there's no GPU, by the way, some of these can actually take like 20 minutes, half an hour, okay? A single image. But I'm just kidding. Obviously, they have a GPU. Still takes much longer than I'm used to. I do my own style transfer up on drive.google.com. So mine are like 10 seconds per image. Wow. Maybe we'll just leave it there, okay? And then we come back to it. Yeah, weird. Just totally weird. Okay, that's algorithmia. And then people are starting to ask the notion of a citizen scientist, right? There's a notion in the US called a citizen scientist. Anybody can be a scientist. Likewise, maybe you can be a citizen scientist. You have crime data, for your neighborhood, or you have neighborhood trash data, where people are throwing trash. Just collect some data somehow. And then, just start using all these tools and doing your own analysis. You don't need anybody. So that's very interesting, right? Like that. See, in a way, if it is that simple, then what we're saying is you might not need data scientists in the future. It used to be a cool thing, but now basically, they've like almost obsoleted themselves. Like these companies came along and said, we'll make things so simple. We don't need to hire like a data science person. Automated learning. All you do is your data set, pick some metrics, okay? Like what kind of error, like what is the lowest error you're willing to accept? And then it'll give you, different algorithms and give you the scores. Maybe you can pick one. It even ranks them for your right leaderboard. Wow. Okay. So very interesting that, you can have this concept called a citizen data scientist. Okay, moving on. We'll take a break in just a little bit. A pre-trained model is exactly what you have when you finish the first half of your homework. The .h5 file is ultimately a weights file. Just has the numbers, the weights in it, but the weights are all mapped to exactly the layers that you had in your Keras, code. Meaning, if you go delete some of your lines in the Keras code, those weights won't match anymore, because when you read it back, you need both the architecture and the weights, okay? So together, the architecture and the weights are called a pre-trained model. It means I can send this combination to anybody in the world, and then they can point the camera, at their dog or cat, and hopefully it'll train it correctly, right? It'll identify it correctly. So that is what you can do with pre-trained models. You can go to a flower and tell you what kind of flower it is, or what kind of mushroom, or what kind of tree, or bird, or cloud. People like to name things, okay? Or even what kind of dog. I don't know what dog breed it is. It'll tell you. So the object detection YOLO, again, I think I brought this up, we'll just skip it for now. It'll ask me, I'm going to say no. It's loading just a 40 megabyte Skynet pre-trained model of all the typical objects in the room. Then if my camera, I open my laptop camera, then select that, right? I'll say no, but see, it's using TensorFlow, and yeah, just quickly tells you like what is in front of the camera. It's so neat. Google then does it to the max, where there's done it to the max, where on the cloud, you can upload almost anything at all in the world. The Google network will tell you what it is. So YOLO is just a small version of it. This is nuts, right? Oh my God. Okay. Just one more time. I'm still just amazed. Okay. Yeah. Okay, so that was all that was. And then YOLO is actually very interesting. Try this for fun. Just go on the shell and then just run YOLO on the shell, okay? Meaning you have locally like a PNG or something, and then it'll just tell you like what it is. See like that, like right there. First of all, this is how you get the actual network, okay? And then there's the weights literally, so just download it. And afterwards, you give it like a local directory, like dog.jpg, call it whatever. It'll tell you like the percentage for what it is. That's so neat. So you can even try this on your own cat or pictures that I give you, and this is what you can do. So this like multi-object detection in a typical frame, there's many things. So it'll tell you all the things it finds. Command line, okay? Because in the end, that's all there is, just command line. And then you can put a simple UI on it. Moving on, TinyMod. Okay, so TinyMod is also a very cool idea. Yet another architecture like YOLO, but now it's called TinyMod. I think there's going to be lots of these in the future where they'll give you like a free network. It's already done. And look at that. You can just point a camera at traffic and it'll tell you. This is what the self-driving car ultimately has to do, right? Okay, so like that. Fair multi-object tracking, it's called FAIRMOT. See, Microsoft and Wojong. Cool. Okay, like look at that. That's exactly what you want. Real-time bounding box object tracking. Oh, cool. Okay. All right. So then that's called TinyMart. You can try that library. What else? What else? I think the server is gone. All right. So I talked about create ML a little bit, cart before the horse, but now you see what create ML is. Again, ultimately, all it is, so once you do that and you have some kind of an image classifier, how do you export the model? And then afterwards, on the other side, how do you read it back? So Apple has a specific format, okay? That's all create ML is. So you can go look at it. You do it probably in Swift or something. Okay. So then it's a very specific architecture that's available on both ends, meaning export and also import. So like that. So once you actually have, by the way, create ML is the export part, core ML is the input part, meaning you read somebody's pre-trained architecture into your Apple project, then they call it core ML. Okay, just do core ML like that. Right there, literally, right? So that's the model that was exported. Just read it back. Too easy. One line. Okay, so that was that. I'm going to give up on it. Okay, so we're going to skip it. Like I said, so this is yet another one that we didn't name. NF is also, just like we said, NCNN up there. There's also Onyx and then also NNEF, meaning there are so many formats now. It looks like they're all for exchange. Okay, this is a big deal in the ML world. One of the biggest revolutions, right? But except Microsoft and Google are proposing something much bigger than this. So GPT is basically a pre-trained model, okay? So generator pre-trained. That's what GPT is, generator pre-trained. Initially, there was a GPT, and then there was GPT-2. Last year, GPT-3 was released. As you go 1, 2, 3, 4, the network is getting bigger and bigger and bigger. That's all it is. So GPT-3 is pretty big, right? But Microsoft and Google want to propose something that has got like 1 trillion parameters. This one, I think, has 200 billion, okay? So they're getting massively large. That's ultimately the point. And so then OpenAI is the company that trained GPT-3, and people are doing crazy things with it. You can basically have it tell you a joke, or you can basically have it do SQL, meaning you train it on a bunch of SQL, and then it'll then write SQL code for you. Or you can store some CSS and then what the CSS looks like. And afterwards you paint like a border, the window border that you want. It'll output the CSS. So people say, wow, it can write HTML code. It's not that it can do this, it can do that. It's more like you give it a pattern of something and then it learns it. All right, people have used it to write like a whole article for The Economist, for example. It looks like it's writing an article about the Chinese economy, but it has no idea what the word China means or what economy means, okay? But it does it. It is all based on this notion of pre-training. So the pre-trained model is what it is. So pre-training got quite large when there was a very specific architecture that Google introduced called Transformer. So Transformer is a very specific way to build neural networks. And once Transformer came along, then GPT-3 was basically an implementation of the Transformer. And now Transformers are getting bigger and bigger. And then GPT-2 is becoming 3 and is becoming the new thing that Microsoft and Google are proposing, and on, okay? Like see like that. So this is basically, like 1.5 billion parameters. But now it's in the trillions that Microsoft wants. So this is what Transformers look like. They're basically encoder-decoder pair, okay? Like even with the VAE, encoder-decoder, like a GAN even. But the encoders and decoders can be stacked. So what you're getting when you stack them, just so you know, is you're getting wider and wider context. It's all about saying, suppose you read all these words, okay? And now you're saying it's taking hundreds of dollars to train. And then you have short-term memory and you say, wow, what are they talking about again? Well, they're talking about training the whole network. You need to remember all of this so that you can understand that word. Humans naturally do it. So now you can do it. You can remember all of these while you're reading that by having taller and taller transformers. Ultimately, that's what a transformer is. So that's why the architecture gets huge. And then you can, I guess, have like a wider context, okay? A bigger context. All right, so GPT is, there's a open source collective called Hugging Face, okay? They always get access. It's a group of programmers. They always get access to all these things that come out OpenAI gives to them. And so then they have one thing called Write with Transformer that is using the older GPT-2. So then you can just type something, I don't know, just say like what a cool day or something. Okay. And then you can have it complete, okay, like that. And then just say trigger autocomplete. So like that. And then, like that. it just keeps going, okay? It just gets more and more weird, but apparently it is maintaining some context. So it is trying to have an intelligent conversation. So you can try it, okay? I don't know what it is. It's weird. It does grammatically correct things at least, okay? It says you are the one. This all takes me back to many, many, many years ago. There was a thing called ELIZA, okay, which is the world's first program that did it. It basically just spit words back at people. Oops, ELIZA AI. Pretty dumb, okay, and quickly made grammatical errors. So GPT-2.3, they're not making grammatical errors, but not much different, okay? Conceptually speaking, they're not doing anything. There's a paranoid, schizophrenic, weird thing called Raptor, this chatbot. You tell one word to it, it'll speak a whole paragraph back to you. Just weird, okay? So that also I've used in the past. It made a whole bunch of poetry that people compiled and called it "The Policeman's Beard is Half Constructed," because that is one of the phrases that Raptor came up with. So what I'm trying to tell you is this all is very cool, but at the same time, I've seen this movie before. And yes, it does get better and better. All right, so you can use this to write like a whole story, you guys. Moving on, tools. Okay, Saweka, I think we named all this earlier, okay? Saweka, RapidMiner, and Crime are all pre-written, okay? They're all just drag and drop tools. And then Bonsai is very similar, it's Python based. But this I want to focus on, maybe we'll take a little break after this. What happens here is, this is all pure data flow, pure data flow. You drag and drop little boxes. The first box says read CSV. The second box says train using Linux architecture. The third box says evaluate training. Fourth box says deploy. You hit click, and after half an hour, your model is deployed. Wow. You don't even have to know a line of Python code. You can do your whole homework this way. This is a company out of Pakistan, okay? Basit was the first one that actually did it. It's very cool. Okay, so look at it. This is what I mean, okay? They can even go to Twitter and actually grab some tweets, okay? And extract data from the tweet. Or maybe in this case, image data. And then analyze, and then classify, and then like deploy. Okay, that's what it looks like. You can do face recognition, you can do style transfer. All the things we saw, okay? You don't need like a line of code because you can just drag and drop those pipelines. See if this plays. You can save that whole pipeline, by the way, it's just a project, right? And then that is basically the program. You can give it to anybody. But here they're going to create the whole pipeline, okay, to drag and drop it. Watch it. You need what's called a node catalog, meaning the things that it can do, just drag and drop it. I believe this is how all programming in the world should be. This is a little like Scratch, okay, if you're used to things like Scratch. But these are more powerful than things like Scratch. See that connection? That's actually a code connection. That's a data connection, even though you're wiring it up. Meaning, it's a data flow. So once one step completes, automatically the next step will run, and that completes, that will run. And maybe you can take both those outputs and go here. That's what they do. So you carefully write all these operators with known data types. So you can only connect things with known data types. Like that data type should match the type. Then it'll work. But not a line of code. So that's what's so neat. Look at it. Nodes are magic. Okay, I've written nodes for like 20 years. Okay, look at that. So just simply supply an image. In this case, I think the architecture is pre-trained. So they're literally feeding it images, telling them what it is. Wow. Magic. Like your whole data science, machine learning is all abstracted in those nodes. So those nodes might look simple, right? But they're doing radically powerful things. Okay, so that was Basit. And just like Basit, there are others, which I'll just simply show you briefly. I want to show the slides. Sorry. Okay, so you see, again, same thing is going on. It's able to classify people and so on. So give Basit a try. What else can I show you? I can show you Percepti Labs. That's, again, a similar idea. It's a much more recent one, probably the latest of all of them. They had the same idea, TensorFlow-based visual modeling tool. Again, they're analyzing traffic, COVID even. And then that's all you do. So you just do that. See that? So then you have a node catalog probably over here, drag and drop the nodes, actually showing you what they do. This is also very cool, by the way, because each node actually has Python code in it. If you double click on it, they'll show you in the editor what the Python code is. You can modify the code if you want, because ultimately the abstractions of code, okay? All right, so just visual debugging, visual modeling, visual deploying. It is neat. So that's Percepti Labs. And you can try it, by the way, if they give you the API, code for it, the key for it. That's simple, it's just ultimately Python. You can bring it up. And then that's Percepti Labs. And then StackML is yet another one. StackML is actually founded by a USC student who's currently in my other course, 571. How cool is that? Okay. Wow, very nice. Same idea. You do like all this, and then it's using JSON to give you the results back. In-browser training, but all based on data flow. Okay, cool. That's StackML. And Lobe. This was acquired by Microsoft. So Lobe used to be their own deal, but now it's at lobe.microsoft.ai. But I show you the article, okay, same deal. So Microsoft quickly wanted this data flow product. So rather than write it themselves, they said, we'll just buy Lobe. And that's exactly what happened. So like that, okay? You can go to your camera and just do this, and then it's gonna, do that. It's neat. So no coding involved. Right. You can write your own operators, and then you can bring in models that were trained by Apple. So you see again how all the things that I'm telling you in different places all come together. So we should play this for a few minutes.
We're the creators of Lobe.
And take a little
So we
break.
know that building deep learning models can be slow and complicated. It can be difficult to figure out where to get started. There's a lot of technical things you need to learn. And even when you're all set up, it's hard to visualize and understand what you're doing.
So we created an easy-to-use tool to make the whole process simple and understandable. Lobe lets you build custom deep learning models, quickly train them, and ship them directly into your app. Everything's done through a straightforward visual interface without any code.
So in this video, we're going to show you some interesting examples of things that people have built using Lobe, and then show you how easy it is for you to build your own custom AI in your browser, and you log in with your Google account. We start you off with a few demo projects so you can get the hang of how everything works. And to help you get inspired, we've got a bunch of examples over here you can check out. Let me show you a couple of these.
So go to Microsoft and look for Lobe. You can still do this, okay?
This example was taught to look at what face a person's making and then turn it into an emoji.
Like, facial expression becoming an emoji. That's neat.
So I can smile. I can frown.
That's very neat, right? Real time.
I can do stuff with my hands.
That's very cool.
Not only figure out
Okay. But, again, don't be fooled by the simplicity. The point is the simplicity, meaning they're hiding so much underneath that. And that's amazing. Okay. So that's Lobe. Okay. So naturally they got acquired by Microsoft. Wonderful, right? Good for both of them. And DataChar is yet another one, finally, Smart Predict. Cool. So DataChar is yet another no-code platform. These are called no-code, or sometimes they're called low-code platforms, okay? So the idea is the same, that you basically don't write too much code or any code at all. See how it's all wired together. Okay. All that. So upload, show you the graphical part of it. Like right there. Custom detection. This might not even, yeah, like that. Okay, right there. So that's your data set, and then this augmentation. Augmentation means take the data set and create extra columns. Maybe it's an image, color correct the image and maybe make different variations, or turn the image upside down, maybe make different capsule rotations, okay? Like augmenting your data. Synthetic data from real data, so they can have more data. Look, just keeps going. And then there's a neural network right there. Then trains it. And then instantly starting to recognize it. You see everything visual. Wow. No line of code was written because it's already written. The last one before the break is Smart Predict, showing you the data flow. So the data can flow from top to bottom, from left to right, right to left. They're all just graphics, okay? And then you can move the nodes around. But what is happening is they're all ultimately staged in the sense, after this runs, this runs. After this runs, automatically this runs. Then that runs, that runs. This cannot run until this runs and also this finishes. Maybe this finished early on, but you have to still wait till this is done. Like again, if you want to compile this code and some change was made here, right? You need to wait for the change to be compiled before you can compile this one, because this depends on that. This include file is included over here. So make file, that's exactly what the make dependency system does. So it's basically a dependency graph. Okay, that's what it is. Okay, so we've gone through like a bunch, right? And then we'll come back and talk a little bit about languages. Why don't we take a 4-minute break? Okay, it's not 5-minute break. 6:12. I want you to come back at 6:16, really. Okay, little 4-minute break. Stop the share. Okay, 6:16, we should start. My screen blanked the third time. Oh my God. Okay, so I'm hoping that the blanking will stop. This is just crazy. So next time I'm going to leave it on. Wow. Okay, so blanked the third time. I hope no more times. Yeah, so unstable. Okay, fourth time. Is 4 a good number? I hope so. Nothing is blocking anything else. Wow, we did it like a fifth time, you guys. Wow. Okay, let's see what happens. Sixth time. No way. Okay, what am I doing? I can try stop sharing. Okay, I'm gonna click stop sharing. Let's see what happens. Okay, I'll try it again. Wow. Okay, so yeah, exactly. You know, you have no idea how mad I am. I don't want to say anything. Okay, you have no idea. Yeah, it's beyond annoying. I mean, if people actually have businesses that run on this, right, they should actually have a class action lawsuit. Is what I think. It's not right. It's not okay at all. I love wasting time on my own, right? Because it's my choice. This one is forced waste of time. Yeah, well, I've restarted. Yeah, exactly. That's a joke, right? Oh my God. I spent 4 hours, okay, look at the first time this happened, trying to uninstall the KBs. It's always something KB. I had a command line uninstaller. It ran for hours and hours. For 20 years, I haven't done this. I'm still like, I put up with it. Yeah, right. It's just so bad. Okay, I'm going to try again. Share screen. Share just the, okay, so just the Chrome browser. I'm serious, right? If businesses lose money, lawyers, you know, charge you like $300 like an hour. So for them, they cannot do this BS, right? They're literally losing like $1 a minute. Wow. Okay. Sorry, it's actually blinking again. The entire screen is just black and just gone and then come back. Can't teach like that. Oh my God. Okay, so what do we do? I'll exit Zoom and come back. Maybe I can try that. Okay, so we'll just give Zoom another try. So I'm going to say stop share. I'm going to say leave. Okay, excuse me. So I'm back. And let's see what happens this time. It's something about the screen sharing, by the way. It's just not able to handle display overlays is what it is. So I have my browser right here. Then I'm going to try saying share screen. Apparently, it seems a little better if I share just the browser, not the entire screen. So launch, meaning Zoom, share. So only the browser is being shared, which you can see. And I'm going to put up the chat. Oh, no. Okay, so it flashes a few times. That was number 1. And then, okay, number 2. Yeah, you see the black screen too. It does it like 4 times, Shamsuddin. So from what I found the past few days, 4 times. There was like 2 already. I'm hoping it stopped. Okay, that was number 3. I'm good now. And then maybe number 4. Okay, so that was 4. I think we should stop after 4. Please, 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 please stop. It's a class to teach. Okay. Okay. I hope so. All right, you guys. So I just have a few more, right? And then I'm going to tell you about all the other things. So let's move on. If all these things, fail you, meaning you don't want to do any of these, I don't like data flow or n equal to 4, that's right. I don't want to use a pre-trained model. I want to do it all from scratch. Once in a while, there's a need for that. Maybe you have a brand new machine learning model that you want to implement from scratch, new bunch of layers, or you have a new algorithm even. You always have languages available to you. So Python is the most widely used one. R is like a statistics language. It's like a pretty old language. My point is not to tell you all about R. You can go read it. But R is a lot like Python ultimately, and R can read like all these file formats, okay? And then R is also cross-platform. I have an R Studio thing that I run once in a while. And then, for example, sports analytics, okay? So you can use R code and visualize things like baseball data. So that is exactly what this is. So, or basketball in this case. So imagine taking an actual, NBA game, and after the game, go plot all this, like where the characters were, and literally do a game analysis, throw by throw analysis. So you can write R code for that, like that. You can even animate them, okay? It's so neat. So once again, if you're NBA and NFL, all that, you're sitting on gold mines because you have all that video from the past. Every single NBA game, right? With Kobe Bryant in it. So somebody can write R code to actually analyze all this. So that's what this is. So please go look at the R code, okay? R looks a lot like Python, by the way. So like instantly you start to see, any one of these .r files, select it right there. Select that. It looks so much like Python, similar idea. Like R has a very interesting operator. Assignment operator can go towards the left, meaning the function is on the right-hand side, becomes a value assigned to a variable. You can mirror flip the entire thing. You can have function, all of this, arrow pointing to the right, and then the word circle fun on the right-hand side. Amazing, okay? I have no idea why they actually put that in there. It's one of the coolest operators. Right, no, actually, it's a different question. Python is from the US, R is from New Zealand, and R is by a bunch of statisticians, who want to make like a mathematical analysis software. So they really have nothing to do with each other. It's just that Python, because it is more general, in the US, people picked it up and started doing machine learning with it. In a way, the more pure language of the two is actually R, believe it or not, okay? R's job is only one thing, which is to actually crunch numbers. But these days, they can do a lot. And just like Python, it's also a functional programming language. You can chain operators. And then you can just exit RStudio anytime. It'll automatically save everything for you. No need to, save it. All right, so all the things you can do in Python, and then, oh yeah, look at this one, just very fast. After Kobe Bryant, passed away, right? They made, I'm so sorry. There's a Kobe, this is called a shot chart, where you can take every single shot that he ever made, just a shot chart, and put it all in just one graphic, right? So how do you make the graphic? That one, like that one. You can use R code for that. It's Kobe's entire NBA career. Every single thing is actually a shot that he made or missed. Wow. Whoa. Okay, so then that's that. Okay, I hope it's not going to flash anymore. So just go to rproject.org and download R. R is in 2 pieces, meaning you need the actual R interpreter. You also need the R Studio front end. So definitely get both. First get the back end R, then get the front end R Studio. R came from S, okay? And S actually came from Lisp and Scheme. So interesting. So R actually like a lineage with the AI programming language. Shockingly, so does JavaScript. JavaScript surprisingly is actually Scheme in like C++ notation syntax. Crazy. Okay, so in R you can automatically make like an array like that. Okay, it's instantly vector type. R has something that many languages don't have, which is you have a single variable that secretly is an array, right? You simply write 1 over the variable. It will make 1 over the array. Implicit for loop. Okay, you don't need like list comprehension or anything. Any operator automatically can either be a single value or multiple values, and then it'll do the right thing appropriately. You can even do this where these are all vectors, meaning they're arrays. So this is also an array. Okay, so R has very surprisingly cool things. Okay, I want to tell you like all of them. R has all these built-in data types. This is a table data type. They have a table data type. So instantly you can load a CSV file into R, start doing analysis. Okay. Okay. So there's like some very neat things, and I made like a very simple chart, like an ASCII plotting chart you can do. All right, so just, super fast introduction to R just for the hell of it. Julia is an MIT-based open source programming language that is going to be an upstart. It's going to basically upset Python someday because it has the full open source community support, and people are furiously taking every single data science library that Python has, porting it to Julia, so that in the future we'll all move to Julia. Okay, see, like top people, AstraZeneca, hey, okay, so they're using Julia to design their vaccine. And then Wolfram is a surprisingly cool, amazing language from one of my most favorite things in the world, Mathematica. So Mathematica itself is programmed in a functional programming language called Wolfram. So Wolfram has all these powerful single word, double word functions that do a hell of a lot, okay? Just like that, you can say classify is going to classify that, okay? So easily. And they can start doing it because it has like almost 9,000 Mathematica functions underneath that can support all this. So Mathematica is like an ocean, and then each one of these is like the tip of the iceberg. Cluster classify. They can run an unlimited amount of mathematical functionality underneath just the one line that you supply, okay? And then it does the magic underneath. So we at USC have free access to Mathematica, so you can try Wolfram. JavaScript has, my favorite language in the world, has all kinds of machine learning libraries, things like brain.js, and then TensorFlow.js, obviously. So you can do all of these things on the browser that you cannot do in other languages, okay? So this is a very cool little walkthrough of all these JS libraries, meaning the source code is just one .js file, which you can install with Node. Just say, npm install, Needaptic, and then you'll get Needaptic, and then start doing things like these instantly. Like we're not going to wait for that to load. That's just simply JavaScript libraries. Scala is yet another functional language, and then that actually runs on the JVM, so you could do that. And then Scala also has like a pretty seriously cool bunch of libraries. You can do raw Scala programming, but then use some of these libraries on top of it. So you should be aware of all these options, not think that everything is just Python. There are other languages that do similar things. So again, the more you know, the better you'll be. Good old Java, right? So don't forget Java. Although I'm going to say Java is one of the least used languages in data science and machine learning because other alternatives are actually pretty good. Java gives you robustness, right? Memory management, right? All those, like safety. So then there are some libraries after all, like deep learning for J. And then the Cypher, language, all that is written in Java. I told you Neo4j. It's like a big graph database that's written in Java. But otherwise, we don't do a lot of Java. Weka is like a big jar file entirely written in Java. So I talked about Jupyter earlier. Jupyter, by the way, is an environment, meaning it's a notebook environment. Julia, Python, R. The three things that I named there. Julia, Python, R right there. That's what Jupyter is. But Jupyter has plugins. So by plugins, you can bring in things like JavaScript. Jupyter has a massively large number of notebooks. You guys can learn everything in the world with these notebooks. Oh, okay, here. Interesting. This is actually not what I wanted to show you, but it's okay. Okay. Very quickly, I can maybe tell you. Okay, so I'll just say Jupyter Notebook Gallery, okay, because that was not very impressive. Jupyter Notebook Gallery is what I want to show you. Everything from biology to art to statistics to economics to machine learning have all been made into notebooks. Is this where we went? I'm not sure. I'm going to go there. Okay, go here. Look at that. So you could literally click all day through all of these notebooks, right? And then they're all notebooks you can load. So now you know how to do a notebook. Go into Colab. So do it all in Colab. And we're just at some random, it's not even, machine learning, signal processing, scientific computing. So no matter what, area you're in. So look at machine learning itself. You can learn machine learning, all these things. So for example, linear regression using Python. So we went through linear regression. You want to try out an experiment. So just get the notebook right there and use the standard libraries that Colab already has. So just get some CSV file from the web, just read it from your own G drive possibly. And then instantly you have the columns, and then those are the features of the columns. And then you can do column versus another column, start doing regression right there. Cool. So easy, okay? And then you can start tweaking the code and just see what happens. Okay, so that's a massive amount of notebooks you can get. Hardware. So again, ML is massive in terms of the data requirements. Therefore, and you also want it in real time. So one of the very first things that ever happened was people looked at graphics GPUs and said GPUs do matrix multiplications. Neural networks, simply the input data is like a vector, and you do a dot product with every single neuron. And dot products are exactly what happened in GPU. So therefore, Google first took NVIDIA's GPU. Afterwards, Google made their own TPU, which is initially just, the tensor library. And then they made TensorFlow and hardware in terms of the chip. Then they pretty much said how their chip is actually better than a stock GPU, okay? This is 2017, remember, 4 years ago. Look at the number of authors. Whoa, they all wanted a piece of this. But then they give you these timing charts, these very dry looking timing charts. But eventually they tell you the TPU is actually better than an NVIDIA GPU, which is why they made the choice to actually take the TPU and put it in the Waymo cars. So in the Waymo car, ultimately what is happening is when you turn the car on, you sit in the passenger side, there's no driver, because all these weights that are in all this memory is being processed through the TPU, the graph, the data flow. But what is coming from the outside is actual live video of real traffic. Then maybe what is going on the outside is the car is applying the brake or making the right turn. The steering is automatically turning. The weights are all right there. It's hard-coded forever. Means it'll work in any part of the US, right? The laws are the same. Crazy. All right. So then just skip the popular science deal. Then Google has a blog post. Okay, like that. So deep learning chip TPU, what is GPU? Also, the graph processor is pretty smart. What I mean is, suppose you make a big TensorFlow graph. You have access to a TPU. You also have access to your own GPU on your laptop. Say you have a bunch of phones sitting around and you have some laptops sitting around. If you're able to hook all of them up together using some virtual network, you can tell the graph processor to parallel process your TensorFlow graph on all the devices all at once. In other words, it'll automatically know all the available hardware, combination of CPUs, GPUs, and TPUs, and then run your graph in parallel on all of them. That's pretty neat right there. Amazon is also working on a chip. It's called Inferentia. I think it's out this summer. So then they have their own chip. There's basically a new race, okay? There's a new, like Wild West when it comes to chip design. Because what companies like you and Amazon, they're saying is, maybe even Google's TPU is not that great. We'll do a better TPU.
As customers, like the Alexa team, know firsthand, as machine learning models become more capable, they increase in size and complexity, driving up the compute costs for inference. We saw an opportunity to help customers reduce costs by developing our own AWS Inferentia chips and EC2 Inf1 instances, custom built for high performance machine learning, the infrastructure spend for developing
responses synthesized using the AWS Inferentia-based Inf1 instances. We are seeing a 30% cost savings over GPU-based instances.
So you heard it right there, okay? Because Amazon was also paying NVIDIA a lot of money. And after Google stopped paying them, Amazon said, hey, we should do that too. So then they have their own chip, okay? All right. So then they'll put obviously those chips in their, AWS cloud and actually sell it to you and me. So we can also use the Inferentia someday. NVIDIA in the meanwhile is still the one to beat because they're all trying to beat NVIDIA, right? So their first, GPU-based machine learning computer, they call it a machine learning supercomputer, is called DGX-1, okay? So we can now buy DGX-1. And so it's basically the GPUs pre-packaged with like a lot of ML libraries. So out of the box, you get basically everything, Keras, TensorFlow, you get it all. See, like right there. And then you just plug and play, okay? Like right there. So there's obviously many companies in the world who still just want like what they have to sell. They don't want the TPU or Amazon's Inferentia. So there's a market for that as well. So let me quickly show you that. I think this is like very cool. Just 2 weeks ago, NVIDIA finished their GPU conference. It's called GTC, GPU Technology Conference. So every year they announce newer things. As a matter of fact, I'm quickly going to tell you what they announced, okay? Okay. So again, a couple of weeks ago at GTC, so Jen Huang in the middle of it, third day, announced something very interesting. They made a new kind of a chip. It is actually called a DPU, a data processing unit. What the hell? That sounds so old-fashioned 1970s IT, but they made a DPU, okay? Okay, so a DPU sits between, the GPUs and actually CPUs. Like, where the heck is that? Geospatial, metaverse, ingredients, comparisons, all of this. Tech Explorer, Perceptive Labs, and yeah, that one. Okay. I put up some very neat things, by the way, in extras. You should go look at it. Okay, so this again, just like a few days ago. Hey, my birthday. All right, so like that. They made a new thing called DPUs. It's specifically for machine learning data centers, okay? Okay, so all this, I'll read it. Okay. So now you have a CPU, GPU, and a DPU. Ignore this, go back. Yeah, more. So Intel has this, Movidius, right? So where again, they have on the device a hardware version of the pre-trained model. And then all you have to do is supply data, okay? They call it a vision processing unit, VPU. So look at all the acronyms, right? So there's DPU, GPU, CPU, there's VPU, vision processing. But it's the same idea as before. This neural network, but now it's in hardware. And the idea would be exactly the same thing. Some car would use their, VPU, and then the real-time detect.
Things, as well as the technologies that have enabled intelligence at the edge, present unlimited opportunities.
Say just not the cloud.
With analytics and AI. But these all require AI at the edge, along with cost and power constraints. The need for intelligent, low-latency edge newest compute-efficient architecture, the Intel Movidius Myriad X VPU. First, the chip architecture is tailored for data flow. In traditional chip architecture...
So again, they got all the TensorFlow kits. It's the best idea because neural networks ultimately are data flow architectures. The layers are data flow.
What's more, Movidius VPU's tools provide automated data flow management, which helps make programming more efficient by handling the data flow and together with an array of 16 programmable slates, such as detection and classification, to achieve sufficient performance.
Cool. So all that is encased into the hardware, literally. So let me then entertain you. I think we saw this. Tell me if we already saw this. Okay, I think we did. Where Pixie2 is this hardware camera that is not outputting raw video, but outputting bounding boxes and object tags, meaning you can train the little neural network on the camera. So Google also has this thing called Coral. It's actually very interesting. Once again, you just plug that in. It's like a USB form factor device, or it's also a chip at the same time, like a little chip. And then there's also something called the Jetson Nano. So this is what the Coral looks like, okay, like right there. And then you can do lots of devices with Coral. But again, what this has in common with things like, Movidius is it's in hardware. So look at how many hardware alternatives now exist. So I just now mentioned Jetson Nano. So this is a very tiny little device that NVIDIA makes. So again, for edge, computing, put it in a phone maybe someday, where Nano is very neat to buy, literally just a little chip, a board, and then start doing things like that. You can make your own self-driving car, meaning a Nano would be a more powerful version of the Pixie2 that I showed you earlier, okay? Okay, so that is pretty much the Nano architecture. Jetson Nano. And then Movidius, I want to show you this. So here, the Movidius architecture is in this thing called neural compute stick because it looks like a USB stick. So the same thing as we showed before earlier, the Movidius, but now it's in a USB form factor. So this way you can put it on your laptop and then your laptop camera can identify things faster. Okay, on and on. There's an explosion resurgence in chip design because ultimately you want to make the training go fast. You also in real time want to make the inference go fast after it's all being trained. So I told you, so again, this NVIDIA not just announced their DPUs, but also A30 and A10. A10 is a smaller version of A30. They announced 2 brand new chips, by the way, so it is, okay? So just again, a few days ago. Cool. So they just keep innovating. Why not? Just a tiny bit of it. I love Jen Huang, by the way, so damn smart. And then for graphics, he basically saved the world by inventing GPUs, okay? All right. Go here. Okay, he's going to talk.
And UC San Diego uses multi-GPU NAND running on Oak Ridge Summit supercomputers. 20,000.
This is the founder of NVIDIA, Jen Huang.
Largest atomic simulation ever. Design collaboration.
Okay, that's pretty neat. So Spot Mini, Spot Micro. Look how tiny that was. You can do all this with reinforcement learning, okay? You can do like a lot of different things in the world. Okay, and then they can put it on data centers.
Cloud computing and AI are driving fundamental changes in the architecture of data centers.
So that's a DPU that he talks about, okay?
320G.
Okay.
Use DGX.
Anyway, so you can go watch the whole thing. It's like an hour, 48 minutes. It's pretty neat, okay? So they keep coming up with cool things. Moving on. Summary. It's like this. So the whole architecture is actually very simple overall. This, in fact, what you're doing for your homework. So you have data collection. We already did this part, okay? Give you a folder full of cats and dogs. And then there's no columns, they're just images. But if you have lots of columns, feature engineering is what columns are more important. And this is the hard part where you do the back propagation. And then you save a little bit of the data you already have and then put it in here and see how good your training was. Okay, that's the validation step, meaning it's the testing step. You do that. meaning it's called the 80-20 split, the 90-10 split, where you take a lot of data you have, don't use 100% for training, because then you won't know how good the training was. Keep 10% to yourself, where you know the Y value, so to speak, and then supply the X and the Y and see what Y it gets. And then you'll know how valid the model was. Otherwise, you might have to go back and retrain is the point. Okay, so once you do it, the next big part is this now live on the web or something, or a device. And this is when you plug in like a new cat and dog, okay? So after this, what happens is, you keep doing this over and over. Once in a while, maybe your whole data landscape changes. So you might have to retrain again. All right, so I wanted to show you that. In the end, this is the whole pipeline of everything, okay? So MLOps is like DevOps. So in standard software development, you have developer operations. Likewise, MLOps is where it happens like this. So initially, you have the data, like where do I start? Let's start with data scientists actually. So this is the part that we commonly do, okay? The model training, model analysis, and then feature engineering. This is the actual part of data science. This is where you need data scientists. But afterwards, when this is all deployed, you need what are called data engineers who scale it up. So data scientists come up with the pipeline and get it all done. And then these people have to actually go on Facebook or LinkedIn or eBay or something and make it be like available to the whole world. So that is a data engineer's job. Meanwhile, you have DevOps, which is basically the software infrastructure part of all of this. How do I actually deploy this? This is more about just the data, okay? Data engineer. Whereas these people are more about any software at all, including data science software. They do all of this scaling, testing, like online monitoring. And then you have data engineers, again, the same data engineers to work with ML architecture. So basically what we're saying is you have these different roles, such as a data scientist, data engineer, and then you have DevOps, ML architects. They're all slightly different, and then they all work together. That's the point. A scientist's job is not to scale things at all. They come up with a formula. They might tell you, I found a new way to do PCA. It does non-linear projection of the axis, okay? PCA does linear projection, it's linear summation. But then what if you want to project it in some spiral axis? A data scientist will come up with some cool projection. Does anybody know what it's called? Purely for the hell of it, I'm going to ask you. There's a projection that is not principal components analysis based at all. You can do non-linear projection of one axis onto another axis. Can anybody name it? Starts with SA and ends with an N. This projection is so cool. It's something, what projection, okay? Anybody? Hangman. Oh, everybody died. It's salmon, okay? Right. There's a projection called the salmon projection. You can go on Google. It's a say that has a good place in this pipeline. The data scientist would suggest that. The data engineer would then have to scale up all of the pipeline so that it can now handle salmon projection, okay? So the classic scientist engineer split. You come up with some new invention, then they have to actually build it and productize it. Cool. And DevOps are classic good old software developer, DevOps. But you have the ML architect, whose job is it sits somewhere in between a data scientist and a data engineer, because they would then take what the scientist came up with and maybe optimize the design, okay? That's what this is. So optimize the runtime. And then the engineer can then pile on data on top of that. So, different roles, okay? Some companies have like all of them. And just one last slide. Shraddha. So there's like a person that has a blog, you can Google her, Shraddha. And she just explains to people like what all this is, okay? So like here, product manager, you have a new product, maybe Grubhub, it's based on machine learning of people's food preferences. Then the product manager steps in, data scientist comes in. Usually there's nobody in between, there's no ML architect, okay? This person becomes ML architect. So then they do what the data scientist did, but on a bigger scale. So and then, in the meanwhile, you have like ML engineers, DevOps engineers. Cool. But it's all based on data, okay? What else? I think that was it. Cool. Okay. So this was longer than I thought, but it's okay. I'll catch up though. All right. So, but I hope it was useful because you found so many ways of like not writing code from scratch at all. That's what it is. And then even doing things in hardware because that is where they're all going. So I can now, without missing a stride, just go do something else. So now I can show you the other things. We can get a little bit bigger here. We can now look at data visualization. So this is an easy, simple little lecture. I don't have any big principles to tell you. In fact, I have pretty pictures to show you, and just give you the whole big picture of all of this, so to speak, which is you want to then get a picture, for example, right now, of languages spoken in the world. In one glance, I want to be able to say, wow, look, a lot of people speak Chinese, and I did not know Portuguese was spoken by so many people. This is literally a visualization of how many, million people, the numbers, speak that language. This is called an infographic, right? Or a data chart. So that is what data visualization is all about. Yeah, me too. I also love visualization. Exactly. So I'm going to name all those, Yash. So what tools, what principles, okay? Why do you visualize? Humans are visual creatures. It's that simple. 50% to 70% of our brains are dedicated just to vision processing because nature thinks that our eyes are so important. So data visualization is simply, we have INF 554, by the way. So in our USC, right? INF 554 is a data visualization, I believe, for USC. You can even take a whole course on this if you like, okay? Okay, so that, cool. Information visualization, same as data visualization. The idea is pretty simple. You take like raw numbers, ultimately just to generalize it all, and then turn them into pretty pictures. You can read a Wikipedia article about it. Okay, so it's a neat idea because we cannot deal with numbers, humans. We're not good at numbers, but pictures, absolutely yes, because it's all about getting a quick insight. Maybe your AI ML program does not need graphics, okay, but we need graphics because you can use it to understand something, to communicate with other people, and then to finally make decisions as well. So I'm going to show you what can be visualized. How can you visualize it? It's a very easy, lightweight, okay, have like no equations, nothing at all, just pictures, okay? If you just have one variable, such as Netflix every evening says, today, all over the world, what are the different kinds of shows that people watch? They can take all the data for today and make a simple pie chart, one variable, which is show type, like TV type, movie type. And instantly somebody can say, wow, look, comedy still is quite popular, 20% of the population. Sci-fi is also popular. Action is the most popular of all. And people don't like drama, okay, as much, so only 5% of the population. Netflix can do this every day, or they can do it every hour, or they can do it per country, or they can do it differently for men, for women, on and on and on, okay? So these days we can do a lot, one variable. A variable can also be plotted this way. So in this case, say this like ages of kids or something, right? Maybe it's some party that happened. So different kids for ages from 1 to 17, how many of those age group kids went? So maybe 1 year old, maybe it's not a party for 1 year old. It was just one baby there. And teenagers, get pretty bored and leave. Maybe it's a party for tweens. The 9-year-olds showed up a lot. This is literally how, for example, your exam scores, when your final scores are going to look like. So this is all of you, how many of you? And this is how many people got 50, 51, 52, 53, all the way up to 100. So I plot exactly a chart like this and I say this should be A, this should be A minus. It's basically just a very simple bar graph, okay? Okay, so then bar graphs, this is called a single modality, meaning there's only one peak, right? So unimode. You can also have multimodal, meaning you can have more than like one peak, okay? Like a bimodal distribution. And then you can have like more than one, like you can do the same thing for men and women, for example. Then you would call it like a double histogram. Look up also words like density plot. I'm just giving you other kinds of visualization types to look at. You can also take something and then make its radius be proportional to how important, how big it is. So green tea is drunk by a lot of people to be healthy. And then a lot of people take folic acid or, eat vitamin D tablets. This is the only thing I take every single morning, just one vitamin C pill. So in one quick glance, I should be able to know what are the most common health supplements that people like in the world. Fish oil, not so much, okay? So these things that are very small, aloe vera, you don't actually eat aloe vera. So that's relatively small. That is all a bubble chart is. So the radius itself tells you how important it is. But additionally, you can have an x-axis or a y-axis. Be the x-axis all about vegetarian options, y-axis is meat options. So you can use the xy for extra dimensions as well. Wordle is literally a word chart. I can take a whole book and summarize the entire book using a chart like this, and then instantly I can take a look and say, I think it's a book about students and information. How do you know? Well, because the word student occurs the most. It's so easy, right? There's something about gardening probably, right? What do you guess? What do you think? What do you think this is about? Just very quickly, what word would you use to describe whatever the heck this is? What is it? What are they talking about? Yeah, something even more general. You're right, but something more general than insurance. No, word cloud is the kind of graphic that, yeah, exactly, law. I would say courts. Actually, not science, It's more like claims and actually, wait. It might be science, actually. Sorry. Yeah, that is beautiful. Shovik and Daniel. Hey, Garima, James, you and I got thrown off by the word claim, okay? It's a scientific claim. We're wrong. Okay, so anyway, I get the idea, okay? Just very easily, hey, look, it's about China. But the way is, how do you form it? You take a piece of text and literally calculate, count how many times a certain word occurs, and then make the word be that size. There are Wordle generators, okay? Do Wordle JavaScript and copy and paste this, you'll get a Wordle for that. So you can absolutely try it. There. Oh my God. Okay. I won't do it at all, okay? But I'm going to just tell you to do it. JavaScript. I should fix that. Okay. Literally go here and just copy and paste anything, you'll get it. Okay, look right there. Okay, I'm gonna break my promise. What the hell? Okay, copy it. Because it is that easy, okay? Control A, Control V, go. Okay. Ha. Okay, so this is exactly what we got. It's about charts. Hey, not bad. Okay, so very easily able to generate, okay, your own Wordle. Moving on. So that's a pretty seriously cool form of visualization. This is called multivariate data. So what if you could just take one graphic like this and then depict so many types of data all on that same graphic? This was done way back, okay, 1869, 50 years after the Napoleon disastrous war. Napoleon started here in France, took his army all the way to Moscow, got his butt kicked, came back. And this is how many soldiers initially went. That is how many soldiers came back. So basically decimated. This graphic shows it all. It even has time in there, like when, like where they were at what time. And then, you know, how many troops were left, that is the thickness of it. Even the altitude and temperature. All of it in one graphic, okay? So this has been called the very best data science graphic in the world. Done in 1869 with no Adobe Illustrator, no Python, no computers, okay? Done by hand, watercolor. Go read about it. Okay, so the best graphic ever produced. This guy was an engineer, by the way, the guy, Charles Minot. Okay, so beautiful. And this also historic, 1864 or something, I believe. There was somebody called Dr. Snow. He noticed that a lot of people in London are dying because of cholera. Obviously, the new cholera is an outbreak, but they want to know where the outbreak is. So they literally took every single person that died, went on a map of London, dot, 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 every dot is somebody died. Then they noticed, wow, why are there so many dots here? Go there, there was a water pump. So everybody went there, went to the water pump. The water pump had cholera. They took it back and died. They closed the cholera pump. In a few days, the infections went down. One of the first cases of data-based, you know, medicine, right? And now we do this to Zika, to Ebola, to COVID, every day, literally with COVID. That's how disease spreads, so we can take a look at it. You can also plot crime on a map. You can also plot the locations of Starbucks on a map. So plotting things on a map is so useful. That is why your national, you know, parks project that I gave you was all about national parks all over the country. And now you can use Mongo to actually cut out like a little region. That's pretty cool. Okay, so spatial data analysis, okay, spatial data visualization. You can visually look at it. And then this is actually very interesting for product placement. That's also a kind of graphic, okay? You can take your products that are in your store, your grocery store, and then do some analysis on how people like walk back and forth in your store, and then cluster them in a certain way that you minimize walking, okay? This is a store called, German-based store called Aldi. So this is all about Aldi. So when you walk into Aldi, it is so different from Ralph Savant's. Like, you know, why is this different? Because they have their own database reasons for doing it, okay? Yeah, that's what this article is about. So studying something spatial can actually tell you how you can rearrange your products. Okay, this kind of a data is called a choropleth. See that word choropleth? A choropleth is a map where there's a value for everything. The NPS map that I gave you is not a choropleth because there's no national park all over the US. This means whatever scale this is, I can put my finger anywhere and get a value for it. It's a continuous map, okay? It's called choropleth, meaning there's a value for every point in space at a certain region. But this is also continuous, so it is called a continuous choropleth. There's no color differences. If I class it, meaning if I bin it, if I divide this into 5 parts and say low means 0 to 5, medium means, you know, 5 to 15, and high means 15 to 30, what, then that is called a classed choropleth, okay? So this one is unclassed right here. A classed one looks like this. So that is your class right there. You know, just separate it. Okay, so you can have class choropleth, unclassed. This is also classed, right? Overdoses by county in West Virginia. It's very sad. People got addicted to OxyContin, this crazy, powerful drug. And so then how many people died where? Sadly, in southern part, a lot more deaths. COVID-19 distribution, right, is very sad. India is being ravaged now as we speak. It's pretty horrible. But then, you know, you have to plot it and actually see like where it's going. And so there's a dashboard that's made by Johns Hopkins. In fact, this uses ArcGIS, okay? So it all like comes back to like things we've studied. Oh, cool. It's going to load the data, and then there it is. Okay, so then that's the point of visualizing, you know, health data. Very extremely important. And then class choropleth segmented by US counties. So let's quickly go to that. Right there. How many counties do you think are in the US roughly? Anybody? more than 1,000. You can Google it. Okay, I'm going to keep going. You can plot data spatially. That's called spatial data. But sometimes spatial data also has a time component. So maybe there was, a hurricane that crossed, here. But then the next day the hurricane went there. Afterwards the hurricane went there. Then it went there. So then that is really how you plot basically an animation all on the same graph. Then that is called a spatial temporal visualization. You can obviously animate. Okay, this is what we're used to. But then you can also, not animate. So that'll be a literal animation. How is the hurricane moving through space? It's crossed into this island, and goes back and goes into Florida. So you can take data you already have and actually make animations like these. Okay, you can study them. Okay, so these are not pretty in terms of pretty CSS color gradients and what, but they're pretty informative, and sometimes that's all the scientists wants. There's a Sandy Graphics Archive. And then this is what you see like on TV, right? Again, the hurricane is pretty small. Then gradually, like becomes bigger and bigger. This landfall, that's called landfall when it crosses into land, and then becomes heavy rainfall and just disappears. Sometimes they start smaller and get big, and then get small and get bigger again. It's the magnitude of the hurricane. But hopefully when they do landfall, they get smaller and smaller. That's literally the arc of the hurricane. One more. This is only one hurricane. The National Oceanographic Atmospheric Administration in Boulder, Colorado, NOAA, NOAA, they have every single hurricane ever, every single storm ever, all in one database. Okay, this is basically the NOAA hurricane database, like this hurricane database. You can then Google all of this afterwards. Hurricane data. You can put in any year you want, or things like Sandy, Katrina. They'll actually show you exactly what the storm was to give you data about it. And you get them in so many formats and so on. Okay, you can even fill in some forms. You see data, right? Ultimately, what's behind all of this is data. This all turns into some SQL probably and just runs. Okay, it's a better UI for it. You can look for it. Then they visually plot you every hurricane that happened that you're searching for. Probably that one, I think. Okay, exactly that. So I'll let you search afterwards. Okay, I call this. Just start searching. Whoa. And then they give you the raw data set. If you want, you can even just get the data and plot it yourself. Cool. Interaction is always wonderful because, why not? We're all like used to tapping and pinching and swiping. So we're too impatient when somebody just shows you a picture. You want to squeeze the picture. You want to zoom in, zoom out. That is exactly what we can do with modern maps. So modern visualization has the property of not just animation, but also interaction. 100 years ago in a newspaper, you had no interaction, no animation. They showed you a weather map of the day before, you just looked at it. They showed you the forecast for tomorrow, you look at it. But now we can actually, scroll something like here. This is very sad, the USC area is unfortunately pretty, high in crime. And so like that, right? So just drag it like that. So you see how it's animating? So I think it got stuck, sorry. So like that. So I should just go back and forth, it'll tell you. So this is called predictive policing because the LAPD actually does this every day. And then they have a pattern, okay? Suppose vehicle thefts or Grand Theft Auto are actually going in the east. So they noticed that over the past month, more and more GTA cases are going this way. Then they'll start sending more police officers in this direction to maybe stop some others, okay? That has been called racist. It's been called profiling. In a way it is, but they're also going by what the data tells them. Okay. There's a company called Palantir. This company is basically accused pretty heavily by activists, human rights people, for working with the police departments and giving them the software to do all of this. Okay, but obviously Palantir defines what they're doing by saying, "Hey, we're just using data," with basically telling the police where the crime is happening. But look at that. So they have all these solutions, but the main thing that they have is crime. Okay, crime data. They've been actually sued by companies. Okay. See, like, what does it do? We don't collect store. Okay. Well, they have data that police departments give them. And then the data is all deployed in the police laptops. Okay. And that's what they do. All right. So all of this. I'll just say Palantir data. I just say criticism. I have so much that I want you to Google afterwards. Okay. Criticism. Like that. Then you can start to see. Okay. Here's the notion of predictive policing. Some people even think that they help the ICE people like do deportations, okay? Or how much do they actually know about you? So it's all about combining like, that's a little piece of data and building profiles about criminals. Literally tag them. Okay, and then this is amazing. Florence Nightingale, right, was one of the first health-based data scientists, believe it or not. There was a Crimean War in which lots of soldiers died. So good old Florence Nightingale, who actually who thought that statistics and data analysis is how you figure out the mind of God. Wow. If you want to know what God thinks, go and look at data. That's her belief, okay? Amazing. So she takes the war casualties from all these, British soldiers, and then she says, wow, how did they die? Time goes this way. Month, next month, next month, next month, month, and then it continues over here. So she made 2 charts. Within each month, so there's a slice. Each pie, it's like a month, there's a slice. The slice tells you these people died because of actual battle. These people died in surgery. These people died because of unsanitary conditions. They basically got an infection and they died. So she sees that over and over that most soldiers are not dying in warfare. They're dying because the hospitals are dirty. So she goes to Queen Victoria and says, what the hell, we need to fix the hospitals. And then Queen said, okay, go ahead. That's basically exactly what happened, okay? So and then Florence Nightingale is a data science hero, evidence-based medicine, the first health scientist, data scientist. So cool. Look at that. Okay, so these days you can visualize it. That's actually what's happening. So you can actually plot the different types of deaths. Okay, so you see other casualties is black, wounds is red, preventable. All the blue is actually preventable. So they're losing soldiers because the hospitals were dirty. That's why she was showing them. Amazing, right? She had no animations, no visualization to drag through. Just did it all with watercolor. So cool. Okay, so then so now we would call it evidence-based medicine. Neat. Okay. So you can read about her. Statistics as the word of God. Neat. Wow, what a way to think about numbers, okay? It makes sense, right? Because, God wills certain deeds, like, certain, like a war to happen. And then the war just happens and numbers come out of the war. So numbers, in other words, indirectly are created by God. That's what she believed. Okay, so I mentioned all this. Animation is always nice. So I showed you like weather maps where we just static, but this is actually what you see. It's not just spinning, but it's also moving, okay? See that? It's moving. And that is actually cities, okay? So sadly, it's moving and devastating communities. That's what you see. Okay, so you can always appreciate animation or have some control over it so you can animate it yourself. And this is wild census data. In fact, quickly tell me, so the 2020 census was released just a few days ago. How many people are in the US? What did the 2020 census tell us? GTA Live. Yes, I agree with you. I actually look at a GTA mod, okay? On Facebook, there's actually a GTA 5 mod group. They're just crazy. Good. Exactly, 330 million. Very good. So this is the previous census, okay, 2010. It's actually called, well, first of all, let's look at this one. This is a different one. This is called a bar chart race, by the way. So bar chart race is when you actually have populations of different states over the years and then animate the years, okay, and see what happens. Keep an eye on California, okay? Okay, so we're gonna start at 1900. California was nowhere to be seen, but look, okay, so New York was the most populated state at the time. So still 1930s, like 40s, what. And then look, so still like over here, and then 72. Oh my God. So then like no looking back after that. Okay, so Texas is now number 2. Look at that. Oh my God. We found from the latest census, by the way, that was released a couple of days ago, California does not have net migration in or out. We're basically stable at like 40 million people or something. But that's a very interesting thing that we have. Now you have these kinds of bar races with things like COVID, unfortunately. So what country has the most COVID, right? So last year, US was basically nothing and then just shot up. But if you play today's data, unfortunately, it's going to be India, right? But that tells you still like some neat stuff. It even tells you about world's billionaires, okay? So before Amazon, there was no Jeff Bezos, on the map, literally. There were other people like Warren Buffett, like Bill Gates. But now, Jeff Bezos just shoots up. Just watch it. It's actually fascinating. Okay, so these are extremely useful and amusing animations, okay, of data. All right, so then there's also, I don't want to show you, dot map. Yeah, so Reddit has a subreddit called Data is Beautiful. And it's wonderful what they put up there, okay, so please look at it. Unfortunately, they have the Johns Hopkins data for India for the past few days. It's just sad because India was like minding its own business like that, right? Starting in March, it's actually almost vertical. I've never seen a steeper climb, but it's actually one of those. Okay, so people put up like neat things for you to go and appreciate. So then change over time. What else can you do? You can do that. Economies, GDP. How can you visualize it? There, play it, that. Okay, so what countries have the most GDP? Here you see what happens. So can you tell me what is the difference between this and the previous US state population video that I showed you? Yes and no, that might be true. Yeah, it ranks, it's also true, but something else more fundamental is going on. You're both correct, but there's something more instantly you would notice. Not the colors, although that's a good one. What do you mean by slideshow? Actually, maybe you can animate that faster. No, none of these actually. There's something else that is happening, which never happened in the other map. Just look closely, okay? In fact, it just happened. It's not happening now. I'll give you a hint, okay? It happened just now. Exactly. Surya had the perfect answer. Yeah. So the bars are actually switching based on sorting, okay? In the other one, that never happened. Yeah? Good. You guys collectively got it. Wisdom of the crowd. You got it. Okay. So then these days you can do swapping, unfortunately, right? Sadly, coronavirus, same thing. So what countries are swapping? Currently, number one would be India, sad to say. But last year was the US. But the swapping is pretty dramatic. It tells you in no other way, okay? It's like pretty compelling is the word. Like you would wake up and go, wow, I did not realize it was this bad. So if you can grab somebody's attention, then the animation has done its job, right? Okay, thank you. I'll definitely keep that. Should click on it and then hold on to it. Click on it or not? Okay. I want to move on and show you. Wait, I'll just keep one of those. Okay, so this still didn't load. This one back here. Okay, so animation real time. Yeah, real time animation is cool. I want to come back actually to one thing that I want to show you. Is this? I want to show you with all these things I was showing what is called the US racial dot map. It's a very, very interesting map. So US racial dot map. In here, what happens is there's a 2010 census where every single person is a dot, okay? So cool. So take your whole census data and obviously have the addresses. And then you click on it and you will know exactly 1.1%. They're color coded by race, okay? So you can look at it. So the Caucasian population is pretty much like throughout the country, right? And then look at the Hispanic population. So in the 2010s, so still like 10 years ago, it is, right? And then you see they're all pretty much, in the South, but now the Hispanic population is more mixed. So in 2020, when the same map comes out, you would see it more mixed. Look at the Black population. So initially the slaves were all here. When they were freed, many of them went up, right? So a place like, again, like the Midwest and then a lot in California. So it's so interesting how over time, maybe there's like more and more like melting literally going on or not, or maybe there's still segregation. But that tells you literally a dot, a person. You can zoom in, 1.1 person. So amazing is that, right? It's literally dot by dot by dot. Wow. Okay, that's a neat map. It's the racial dot map. Then I want to show you, going back, animation, real time. Yeah, real time is pretty compelling in its own because you sit there and you keep watching it and you go, wow. Even though I don't think about it, this is happening. Like, people are dying with COVID, right? At the same time, babies are being born. But at what rate? While we're talking, these babies are being born. What? Wait a minute. 1 a second. Yes. In fact, more than 1 a second. Obviously, this is not being plugged in right now by all the hospitals in the world. Okay, they're obviously extrapolating based on what data they have. But that is the rate at which babies are being born. Wow. In fact, birth versus deaths. So these numbers, the very simple CSS, that's just a div like text field. So the graphics doesn't matter that it looks pretty, but it's real time. So it's real time, everything, okay? You can even see what countries. Okay, but there's the top two, head to head. So then there's local traffic. This is super cool. Okay, so now I won't do it. I mean, it's just a time, okay? But you can always go and see like live traffic map, right? So useful. And this is what ways, they all use to guide us. But just the fact that something might be blood red is so interesting. There's so much traffic. But if you look at 2 or 3 in the morning, all of LA looks like this. There was a tiny piece of little traffic in Pasadena somewhere. But see, you have all of LA available to you at 3 in the morning. But the map tells you. So how does the map know? How are they able to plot traffic density in colors? What do you think? Notice it's all on just the freeways. What is embedded on the freeways? Like every 10 feet almost. There are sensors, okay? There are sensors underneath the freeways that feed onto the Caltrans computer. There's no camera, there's actually a sensor, a pressure plate. When the car goes over the pressure plate, the plate is compressed and it does a click of 1. It's counting cars as it's being depressed, okay, day in and day out. So there's no camera, it's all just based on pressure, and it's very cool. Now, actually, what I meant was a sensor is really a plate of steel that is underneath the tar that you drive on. It's inside the road, okay? So when the car goes over it, it literally presses the switch to on, and then it counts 1. Which is why when traffic is pretty dense, people are not moving. The click rate is pretty slow. That is why they turn into red. The clicks are going really fast. It means there's no traffic. Just simple sensors on the freeway. Cool, now you know. Earthquakes, especially in California, is a big deal. We'll probably take a break at 7:30, okay? So earthquakes, every single day you can plot the magnitude. I mean, these are all, look at it. 30 minutes ago, what the hell? So thankfully magnitude 2.04. It happens in the ocean. So this is a big deal that, earthquakes happen so much. And so obviously seismologists study the pattern, okay? Earthquake is all about patterns. If the San Andreas is right there, and then you see the pattern for the last month, there's been a swarm of earthquakes all along the San Andreas. You need to predict like a big event, okay? So that's ultimately what it is. Interesting. There are some German sidewalks actually, that are starting to do that, where people actually walk and then they can generate some power. I'm not sure, I should look that up. Thank you for telling me. But definitely this exists as proof of concepts. Just by you walking through, you can put some weight on it. Gives you a little bit of your power back. Maybe power your handheld or something. Okay. So what sense? No, actually what we mean by all this is, imagine you have a freeway. Show you freeway sensors. It's a steel plate that is hooked up to some electronics that counts. That's all it is. Show you freeway sensor plate. Or they might even have like a magnetic loop, okay? Cool, very good. Okay, see like that. So those things are every few feet, so when you drive on them, they just count for you, okay, like that. So if the car goes over, then it counts 1. Next car goes over, it counts 2, counts 3, counts 4. Just counting cars as they go along. That's what I mean by a sensor. So I said it fast, I'm sorry, sensor. Just sensor data collection, because ultimately all data are collected by some sensor, right, or a human answer something. So sensors can be used to collect traffic data by literally putting them on the road. Cool. Okay. It's a good way to count cars. Okay, so maps for earthquakes are important. Stocks, so if you own stocks, this is exactly what you keep your eye on day in and day out, right? So again, just nothing but visualization. So for our amusement, we can watch the whole stock market go up and down, right? Okay, so you can visualize all these. I'm just visually telling you how the stock market is doing, or the whole index on NASDAQ. Cyber crimes, this is something unexpected. As we speak, there are bad people. Many countries, including the US, that attack each other. So a new like a 3D map, like the Google Earth map, is going to show up, and then that map, oh my God, okay. So that map is going to show you locations on the world where the attack starts and the attack ends. Okay, it's a little odd. Usually it loads before now. Go to map again. If it doesn't come up, I'm not going to bother. Okay. Very strange. Usually you can spin the map even, and it tells you, well, at least you can show your data sources. I think it's because of Windows, again, I'm going to blame it. Something about my screen sharing. I think my OpenGL doesn't work, believe it or not. Horrible. What the hell? I'm like, this is the definition of insanity, okay? Insanity means you keep doing the same thing over and over, except you expect different results. Okay. Yeah, too bad the cybercrime thing didn't come up. So anyway, it's pretty shocking to see how many attacks are being done in real time. Okay, they actually show you in real time. You see like all these almost like missiles flying back and forth. It's a crazy way to visualize what is happening. Yeah, these are actually very cool as well, right? You can track like all these airlines. Wow, look at that. Likewise, there's one for ships as well, which is why when the canal, blockage happened like a few weeks ago, then you can actually watch ships being piled up. Okay, so let's move on. The point is, these are amazing real-time visualizations. Every single radio that's on the web. Wow. Okay, this is crazy, right? Obviously, I have WebGL. So yeah, it's because of my screen sharing. I mean, I'm really pretty pissed, okay? You guys don't know. I have no idea how mad I am. Horrible. Wow. Microsoft. Shameful. Okay, so look at this. networks and node attributes. So now you can actually visualize networks themselves, where you can have data on the network. So in this case, imagine there's families. There's like, one side of the family, other side of the family. This person is shuttling emails or, anything, memes that are being passed around. So they're pretty heavily, tight. They're also pretty tight. But this is the link between them. But this could also be scary. This could be a terrorist network in Europe. This could be a terrorist network in the US. This person somewhere in Asia is shuttling messages back and forth. If you do graph analysis, you find this person is the weakest link, okay? Meaning they're like a critical link. So if you find who they are and kill them literally, you can maybe disrupt the activity. So this is what is useful for, okay? So people actually plot them. NSA would once in a while visualize them, but map algorithms don't need to visualize them. They can do graph analysis. What I just now said, what is it called? This graph analysis, there's one algorithm that you can use. So what is an algorithm that you can use to find out what that critical link might be? Anybody? It's not PageRank, but think of those kinds of algorithms, okay? Okay, I'll see if somebody comes up with it. There's a whole class of algorithms that can all be used to do graph analysis. Exactly, very nice, very nice. In fact, this might be called betweenness centrality, right? There's a kind of centrality called betweenness centrality. There's many other kinds of centralities, okay? So you can do centrality measures, but it doesn't have to be visualized. But for a good measure, you can actually visualize it. Then you can know if a centrality algorithm correctly worked or not. You can do centralities on any graph, okay? All right, so then they can all be literally mapped and visually look at it. Okay, so, but you can make your map be more useful when you actually put people's names. Uncle Schwartz is the one, forwarding back and forth. You could do that. You can also make the links be thicker based on the volume of email exchange between people. So these are all ways to visualize, okay? So what countries do in the US do this most trade with? With China and with Canada, you can make them thicker. These are all the top countries trading. So these are all cool ways to visualize network data. It's not spatial, it's a circle, but it still tells you what you need to know. You can now visualize tweets between, who's passing tweets to whom. It's scientific collaboration, actually. So scientists in the US all collaborate. Scientists in South America collaborate. Scientists in Europe collaborate, Africa. But occasionally you got across the pond, people collaborating. And that's what these thin little wires are. But still mostly scientists appear to collaborate, basically with each other in the same continent. This is again languages, so you don't even need a map of the world. You can just take tweets coming in different languages and then knowing that the tweeter's location, make a map of the world. In other words, languages, are spoken and tweeted where they are. In France, most of the tweets are going to be in French. It's a great way to reconstruct the world. You can take all the scientific fields like, astrophysics and biology and connect what is connected to what, okay? So if you want to make a name for yourself, take some science field, take a different science field and connect them yourself. Nobody has linked whatever this is with that. So it's useful for things like that. You can do sports analytics by taking like a sports, stadium, like a field, a basketball court, and then analyzing all the plays, how they happen in the basket. I showed you a Kobe Bryant version of this. So you can use that kind of graphics. Graphics for visualization don't have to be complicated. They can be really simple. In this case, basically the same X and Y axis. It's basically how complex the whole Syrian war, the rebel stuff can be for the US. Because the US does not understand all of the crazy alliances that they have. Iraq is friendly with, Hezbollah, okay? It's like weird. Actually, wait, I don't know what I'm looking at. Iraq is not friendly with Iran. Basically, red means bad and yellow means good. Okay, we'll just leave it at that. And then obviously you're friendly with yourself, so you just make the diagonal blank. So we need to be careful whom we're basically arming and training. If you arm the wrong people, they'll actually turn against you. Okay, that's the whole purpose of this. So just study that plot. There's another plot that unfortunately will not come up for me, which is all the wind patterns in the US. This is basically a wind map. Okay, that's what this is, wind map. Just Google it. And you will see in real time all the wind being plotted. Normally, winds actually come in for California from the ocean. It's nice. During Santa Ana is when Los Angeles burns, unfortunately. The wind direction is reversed. You'll actually see the wind blowing from the mountains onto the ocean. And then LA catches fire. I live here in the mountains. Okay, it's pretty scary. But that you can visualize. It's so cool, wind visualization. This is news sources that we all, found out we're going to. Media bias. So there's no bias at all. Hopefully that'll be in the middle, okay? For example, Bloomberg and IP. If you're far left radical, then you have Daily Kos and, patriotics. On the other hand, if you're crazy right-wing radical, then it's Infowars.com, Daily Caller, Daily Signal, Fox News, ON. Okay, enough said, okay? And then you can use the y-axis for extra information, like why are they good, why are they bad? These are the reasons. So it's a neat way to visualize. This one says, given 24 hours a day, how did the most creative people in the world spend those 24 hours? There goes some data on them. So in other words, most specifically, the creative work, when did they do? Some of them did pretty early, like maybe, like in the morning, basically. Others are like late night owls. There's no pattern at all. And that's what you learn. There's no formula for being creative. You can be creative anytime you want. Neat. Eye candy. So again, just more visualizations. Okay. So Tableau is one of the visualization packages. They always have a neat gallery. Okay. They've got like a whole gallery. This like visualization of the day. You can go visit all this. Okay. There's just so much that we just can skip. Look at that. Because of modern graphics, you can do like beautiful things. And there's literally 170 pages of these. Wow. These are also interactive, by the way. If you click on one of them, they'll give you the data and you can actually play with it. Okay, it's like so many years ago. Okay, so you probably have to load it from some offline source, right? It's old. Good. So lots and lots of data visualization I'm showing you. And then look at this one. A histomap is what we call it. What if you can visualize 4,000 years of history, specifically these groups of people? In what year were they influential? The Egyptians were pretty influential. It's not 1950 now. It is 1950 before Christ. Okay, so then look at what happens to civilizations over time, okay? Wow, they shrink. Egyptian civilization. Meanwhile, look at who's like rising. So with the Indians, okay? The Hindus, they come up and they go down. And then also keep an eye on the Chinese and others, right? Chinese are right there. So it's amazing how civilizations become big and small. They, rise and fall. Some of them literally just die out, okay? Look at that. So the Egyptian civilization, like, what is this? Something that started and ended right there. All practical purposes is gone. Wow, neat, right? And then here we are today. If you extrapolate this, for example, China wants to take over the world. So maybe, in the future, you'll see a map where US is not the big guy anymore. Might be China, and so on. So a plot just vertically of history. So cool. Histomap is what it's called. You're compressing so much data into just like one little, chart right there, infographic. Okay, how do we generate data? You can use just off-the-shelf software like, like a RapidMiner, I already told you. We can use code even. R is just the R programming language I talked about. Shiny is a library in R. One specific library I'm going to highlight because you can use the Shiny library program in R, but what Shiny outputs is actually JavaScript code and data analysis code. It means you can take Shiny's results like we're doing here and then put them up on a web page, and then we can interact with it. That is the beauty of Shiny, okay? It gives you a UI for free. Yeah, how are they all made? No, they're all programmed in C++, actually. All of them are programmed in C++. The end user level that we can do JSON and that will be JavaScript. But the core products still, for the most part, are programmed in C++. Look, so you can just play with the sign amplitude, right? Like right there, just do something simple. But this UI was written for free, you guys. We did not program this in React or something. Shiny gave it to us. The whole, what you see here is all Shiny, okay? Like this. So like this, that Ranger slider. All of this is pre-packaged. Shiny just gives it to you. You basically label this and give it to you, and then you deploy it. Yeah, exactly, correct. So when you drag and drop something, a lot of times, the modules are included. Yes, definitely. Cool. So then Shiny generates JavaScript is my point, okay? Or generates JavaScript. It's beautiful. And the whole gallery has a lot where you can go look at it. Okay, so that you can always do it like that. In Python, you can use matplotlib. So that is a massively large library, which, by the way, you can learn in Colab. So take anything at all, and then drag and drop the code that's going to show up in the Colab, and Colab would run. So Colab would run this instantly, okay? Just play with it, and then you'll get that graph. And then modify something, then see what change happens, and learn Matplotlib. Matplotlib is a pretty useful Python library, but there's something even better than that. It's called Plotly. I'm going to show you Plotly pretty soon. I think we can finish before we take a break. Okay, so you see, practically anything you want to visualize, see exactly they've got all of this, and then just use what they have. You almost have no need to write something from scratch, okay? But if you want to write something from scratch, you can write it on your own and then put it up on GitHub as one more visualization type. Okay, so that is Matplotlib. There's also Plotly, okay? So I'm just do the same thing when I say Plotly gallery, okay? So Plotly gallery is more of a modern map than Matplotlib, more modern module. It also does like a ton, beautiful. The same idea again, there's your nearest neighbors. So say you want to do it through Plotly and then go in Colab and just try it. Again, Colab has Plotly installed. If Colab, by the way, does not have something installed, you can do a shell escape, you can do a bang, exclamation point, and then say pip install space Plotly. And after a while, Google Colab will actually install Plotly for you, and then this will all work, okay? But mostly whatever you want to already have. So you should be able to run it. Okay, cool. JavaScript is amazing. Specifically, this library called D3 stands for Data-Driven Documents. Data-Driven Documents. You program all, they've already programmed all this in JavaScript. Just supply the data, for example, population pyramid. You supply your data as JSON, okay? Oops. Okay, so let's go here. Observable, by the way, is basically a Jupyter notebook, but only for JavaScript. Okay, so US population by age, it's got some animation going. All of that is done with just this little piece of data right here, okay, like right there. Actually, mostly it is all just setting up the graph. The data might be somewhere at the bottom. Okay, that's it. So all of this would actually open up into JSON, okay? So you specify using JSON all your data, and then D3 does the rest. So D3 is a visualization package written in JavaScript that runs in your browser. Incredibly beautiful, because again, all the, I'll just say D3 gallery, I shouldn't even keep going there. Okay, so D3 gallery. I use this a lot just for my own purposes. And yeah, I'm just amazed at how extensive it is. Look at this. I spend like hours and hours and hours on this. I showed you bubble charts before, but you can have bubble charts inside bubble charts. You can have zoomable bubble charts, hierarchical bubble charts, your contours, hierarchy, circle packing. And then you can do tree visualization, just hierarchies in beautiful ways. These are all live, by the way. If you click on one, all the links, and if you pass your mouse over it, see like that. So then you can add more code to actually turn them into real links or pop a little bubble. All these are programmable, like right there. And it's function chaining, okay, see like that. So this is the actual graphic on the layer called SVG. Dot append, dot select, dot data, dot join, dot attribute, what, and then make it interactive. So you just program so easily, just pile events on, and then it'll do it. Protobase is an older version of D3. I'll skip it. This is for computer science, you know, people that write papers, right? You use LaTeX, which is a markup language with backslashes, and then it makes them into beautiful PostScript and PDF for you. The same LaTeX can also be used for making images, meaning that chart came from that. It means I can paste this into my computer science paper that I'm writing, and my paper would then have that graphic included in it. So it's a cool way to generate graphics for LaTeX, you know, paper writers. Every CS department, you know, professor in the world uses LaTeX. Okay, so it's a LaTeX library. And then these things, you can just drag and drop your data, you can type it in, and then you get a very simple image for free, which is your visualization. Suppose you want a pie chart. You can generate a pie chart by installing nothing, by just doing like what they tell you to do. Say you just want a plain pie chart. You don't want to color that, okay? And then next I'm going to enter some data. I'm going to just say, I want number of slices. Okay, I'll just say I want 2 slices, okay? Okay, and then slice details. So slice one name is called A, and then its value is like, I don't know, 13. Slice B is B, value is 100. Normalize it for me. And then just simply find it. Data, choose your labels. I already did that. Graph title T, okay? And then display a chart. So it should be as simple as that, okay? And now you can just save it. It'll probably appear, download in that format. So that is as simple as graphic creation gets. So we can definitely do that. I see, okay, I'll keep an eye on that. Thank you. DeckGL, oh, I like GL stuff. I'm gonna go there. And then, so these are all the same, okay? I'll just show you one more. They're all just sites that have sprung up for business, casual business users who quickly want like a piece of graphic for a PowerPoint for a meeting. They're not gonna run Matplotlib, you know, or do Weka or something. So then Slumma is the answer, okay? Everything is template based, but Slumma is actually powerful, meaning they give you a whole dashboard full of visualizations if you want. If your data is complicated, you can then put all that in Slumma online, and then it'll give you the whole, what's called a dashboard with multiple graphics embedded. So that's quite cool that you can do it entirely online. Okay, so these are all math packages. Mathematica and MATLAB. I already named Mathematica with Wolfram, right? You can do all the graphics with Wolfram. MATLAB can also do graphics. It's a little bit more engineering oriented, more plain, more boring, but it does work, okay? Again, say you want to take the national products data set that they give you and then plot it using MATLAB. Many of you know MATLAB. You can do the same thing. See, like right there, just say the word geoscatter, and then it'll actually work, okay? Like right there. So you could take the homework data that they give you or the one you collected, or even a spirograph, and actually do it on the world map using MATLAB. You should try it just for fun. Origin Lab, and then the alternatives. They have only one purpose, which is just to plot. So here the idea is they have beautiful plotting capabilities, and then I'll just go through like a file open and load a CSV file or JSON or something, and they'll plot it. So no need even to run matplotlib on a cell or something. Okay, many people don't know how to do that. So it's basically pre-done graphics. Again, just all you have to do is supply your data. Okay. Again, it's as simple as, I mean, look at every single one opens up into even more and more kind. They basically thought of every kind of graphic in the world, right? So therefore, what you can do is go into Origin Lab and say, hey, guess what? D3 doesn't have this, or maybe Matplotlib doesn't have this. I'm going to add it in. So that is how you make those things even better. All right, so Excel in Visual Basic, you know, if you want, you can extend it. Or Excel actually comes with very plain, boring chart types, but it works. Say somebody wants to, you know, look at how many animals they observed, you know, throughout all these months. They want like a little graphic for that, maybe a pie chart. They can pick from this and then just do a little bit of clicking, and then they can get some graphs. Okay, so easy. The graphs are plain boring, but they're still a graph. All right. So in the interest of time, I'm just going to go through only some of these, right? Maybe I'll show you Periscope. So Periscope is now cloud-based. These are all cloud-based. And so they just simply take your data and then do all the analysis and plotting on the web, okay? And you just download the results.
Whether you're running queries or running businesses, Periscope data helps everyone in your company answer complex questions using data. Our BI and analytics platform.
Okay.
This allows every team. Email form.
So like that, okay? I mean, you can do analysis, and you're not a programmer. You're basically, you know, your business. You're a so-called business analyst or a manager, and then they can do it all themselves, okay? Okay. So salespeople obviously love it because all kinds of sales data. And then Click is also a very similar platform, but Click here, they show you something different. Many police departments, emergency 911 operators actually use things like Click. Because the emergency operator, when you call 911, has to know where the nearest police car is to you, so they can dispatch it, so they can save your life. That kind of police car locations are actually managed by things like Click Dashboard. A human looks at it and actually calls the police, okay? The dispatcher does it. So this hospital data, again, with COVID, it's so relevant, like all those numbers, right? They're all being crunched somewhere.
Enables them to zero into the lowest level with having 5 patients and the journey throughout the EI.
Time of day, this allows us to move.
Okay.
So we've used Click.
So let's look at the next
So
little.
we've used Click to help inform us about our call demands at any given time of day. This allows us to move staff to ensure that when we really need them, they're in with us. We're now recognised nationally as one of the best performing forces for our 999 call handling response.
If you go to England, don't call 911, call 999, but same idea. So there it is, right? And then Domo Jump. So Jump is one of the older platforms. It shows, okay, the graphics is pretty plain, but a lot of people trust Jump. They've been around since the 1980s. So they give you boring looking graphs, but it's still a useful graph. So they have all these scatter plots, you know, like graph builder, bubble plots. Here's when you plug in your own data. You see how, again, so many people have a web-based interface. And maybe the last is Mode Analytics, okay? So go to Mode Example Gallery. This, again, highly, you know, extensive. And all you have to do is click on one of them, and they will actually give you the data for it. And just click on it. Oops, that's not good. What the hell? Weird. Okay. That's very strange. Okay, so we had Choropleth, and here you can actually play with the Choropleth. Okay, you can load the data. So again, try all this, you know, in your spare time after this course is over. It's pretty neat. Okay, so then show it up. Then hopefully there's some kind of, you know, UI. This one is probably just plot only. I don't know. Many of them are interactive, so you can try it. Okay, that was great. And so the point is, you know, look through all of these and then try and find something that you want to implement and see if you can implement it yourself. Okay. In JavaScript, you can actually use the code field that you probably used for your homework one time. Okay. Hey, I might as well do 2 more. The science is what you would find in a course like INF 554, because there is some science after all, which is what colors look good against what other colors. And then, you know, what kind of font should I use, or even what chart type should I use? Would a triangle be okay? Or should I make it into a skull that scare people? All of that is psychological, things like visual perception. So there's a lot of art, graphic design principles. Okay, that's what all of this is. And then you marry that with your actual graphics algorithms and your, you know, data science algorithms. So it's a very beautiful meld between art and science. There's a great book called Atlas of Knowledge Anyone Can Map. This book you should definitely look at or buy. It's a coffee table book. It's fat, huge, beautiful. I have it in my office. that have not visited in the past 1 year. Oh my God. Okay. So then that has all these gorgeous graphics, page after page after page. The first half of the book is all graphic design visualization principles. The second half is all these kinds of examples, like what can you do with all the knowledge that you learned. Okay. So I got this from the first half. Okay. Okay. So then it's all the basics, but you can do like way more than that. And then the course that I showed you, then, if you ask me what is a good design, once again, it's a lot of art, meaning it's the design principles. And so then this makes for a good design. Like nobody should say, wow, what a beautiful chart. They should say that second. They should first get the beautiful effect that you want from it, meaning you should want them to learn something or realize something. And afterwards say, wow, this is also a great chart, who made it? In other words, you want the function to be first, form second. So the graphic design comes second. Conversely, the graphic design should not be so horrible, like contrasting fonts that are so ugly that people lose the message and say, oh, this looks ugly, who made it? You don't want that either, okay? So it's a good balance. This guy is the world's best data visualization expert ever. The Da Vinci of data. So we go to tufty.com. He wrote a book called The Visual Display of Quantitative Information. That book is the very best book ever about data visualization. And then he wrote these other things. I have them all, okay? You should just look at it at some point. They're just fantastic, page after page after page after page. Okay, you guys, it is 7:36. So we will come back at 7:41. Okay, so 4 minutes we can come back. Yeah, it's 7:40. Okay. So what else is left to talk about? Okay. Looks like we're slowly landing this plane with all of you in it, all of us in it. That's what it feels like. Okay, so this bunch of slides is very simple in terms of like not containing actual, database concepts. but it might be one of the most useful lectures of all, in a way, because our entire course is dedicated just to this. Their entire organizations, their entire people and companies. It is basically everything else other than a MongoDB and you running a little, graph query search or writing SQL. Because in the end, what is all this about, right? It's all this about real world data, which involves real people. So as engineers, computer scientists, data scientists, we usually don't think about these, but these affect us every single day. So it's a big deal. So I have an acronym, right? Like GPS, etc. Okay. Meaning 6 related concepts I'm going to tell you. And they're all very easy. So I can ask you like a few simple things in the exam, but just at a very high level, I'm going to walk you through it. Again, don't get obsessed about exactly, all every single bullet point that's in here, but the idea is all simple, okay? Actually, I can tell you right here, and then we'll just rapidly go through the slides. And then if there's an extra time, come back, but otherwise no need. Because they're all obvious and these things have come up before, but they're important. We have to know that they exist and it's a big deal in the world. You'll know by knowing how, for example, the European Union behaves, meaning they're passing laws as we speak about what AI can do, meaning what machine learning can do with data. A few years ago, the same European Union, 29 countries, passed a law for all of those 29 countries, all of EU. It's called GDPR, which is actually in one of my slides. General Data Protection Regulation. So things like that tell you how important, oh, it's so cool, how important, those laws are. So US also has a version, it's called CCPA, but it's not there yet. Yeah, the exam starts at 8, that is correct, sorry. That is set by USC, by the way, it's not set by me. It is absolutely the date and time are both set by USC. Unless every single student signs for an alternate time, the time cannot change. Yeah, so basically I won't even try. Sorry about that. I usually don't wake up that early, but hey. Okay, so I'll tell you what these are. These are very simple. Let me start with security, then privacy, okay? You need security before you can have privacy. Security is just a very simple idea. How secure is my data? I stored my credit card number at homedepot.com. And then they mailed me and said, sorry, your credit card number was stolen. Your card is probably going to be hacked. You should get a different card. Wow, there was no security. So security breaches are basically data breaches. Passwords are stolen, emails are leaked, or credit card numbers are stolen, or your identity is stolen, your social security number is stolen, somebody becomes you. So they're all based on, data that somebody steals because somebody else did not protect the data properly. They did not encrypt it, or they left, a publicly available file open that I know the file name, I can type the file name and all my data just shows up here. As dumb as that sounds, right? That's exactly what happens in many companies. Data breaches, data security breaches don't have to happen at all. They can be 100% prevented because they're a technical problem that can have a technical solution. But sadly, it is because site administrators, website administrators don't bother to install maybe the latest Linux patch, for example, right? Or install best practices like passwords. They let people pick ice cream as the password. You have to enforce that. You should reject those passwords. But if you don't, some person is going to guess that ice cream is your password. So security breaches are preventable. On the other hand, privacy is not preventable, meaning it might happen, but you can only prevent that under the threat of law. So you can tell somebody this data is private. If you actually steal it, show it to somebody else, you would go to jail for that. So things like HIPAA, so in the US, the medical data is protected by HIPAA, right? So the HIPAA law that says only a doctor and the patient can have access to things like how much blood sugar Citi has, or Citi got tested positive for AIDS virus, stuff like that, right? Or maybe Citi got COVID last week. Those are all things that maybe somebody else should not know because they'll judge me and also maybe deny me future employment. If I had COVID, then somebody might tell me in 5 years, your brain is going to be all foggy, so I shouldn't hire you, stuff like that. Okay? Or an insurance company is going to deny you coverage because they already know that you have some horrible disease you'll file a claim for. So we have laws in the US. So things like FERPA, right? So FERPA is the educational version of HIPAA. So if you, send me things about your GPA or your transcript, I really shouldn't show it to anybody else, and I don't, because that is supposed to be private data. For kids, it's actually called like COPPA law. It's for elementary school and young children, but very similar. Children under 13, same thing. Okay, so privacy is really what's behind all of that. We need all that data to be private. So the only way to make it is have a rule, literally, and then punish people if they break the rule. Ethics is very simple. Something is unethical So but why is it unethical? For example, say you punish black, say there's a machine learning algorithm that predicts how much punishment a criminal should get. Somebody got caught with maybe some cocaine in their pocket, right? Then you input all the data, into the machine, what. And finally the machine says, the algorithm says this person should get 20 years in jail. Okay, so that's fine, you give them 20 years in jail. Then somebody else comes along the next day, very similar data, one minute little difference. And then it says they need to get maybe 1 week of probation. And I think somebody that watches this should say, hey, wait a minute, what? This looks identical, what is different? Wow, the first person was black, the second person was white, literally. That is horrible, right? But that is exactly what can happen if you have data that is already bad in the sense because of, racism. Police departments courts did have basically bad treatment, bad punishment for the black people, and then basically a slap on the wrist for the white people. It is what it is. It's history. You can go and change it, but it's what it is. So the machine learning algorithm learns it and then basically propagates the stereotype. It keeps the bad stuff going. So that would be unethical. That's one example of unethical use of data. Somebody should audit the data and say, that race column, we should probably remove that and see what happens. Okay. Or collect more data for white people. Whatever you do. That is all called ethics. It's breach of ethics. Trust has a lot. Hey, you guys, you can do that, but also pay attention to this, okay, please? Like having a little parallel conversation. So trust is really between two parties, meaning I trust you with my data. Say I trust my hospital with my data. The hospital turns around and sells my data to maybe like an insulin manufacturing company. And then the company or the hospital does not tell me that they sold my data and somebody bought it. And they all become billionaires and they retire. I had not even $1 given to me. That would be a breach of trust. Like you never told me you were going to do this, okay? That is breach of trust. And once trust is breached, it is very, very, very hard to get it back. I'm going to actually read like what is being said, and like get the conversation back to what is happening. Are the keys encrypted? Okay. Password, yeah, right. Vulnerability. Well, I also want to then jump in and answer, okay, because it's important. What it is this, okay? So when you pick a new password, they make you pick like a huge password, right? Probably the Google Password Manager picks it for you, which is nice, a bunch of letters and numbers. And then it retypes it for you. As soon as you say accept, here's what happens. That password is encrypted in between you and the server. Like anything that has got HTTPS is being encrypted, okay? Hey, you guys, can you not ask questions? So let me talk and then you can ask, okay, please? Because otherwise you have this thing going on the side. I'm trying to answer you. All right. So therefore, we submit the password that we have encrypted. It's called a session encryption. The server gets it. So nobody in the middle can steal it. When the server gets it, if somebody is able to catch that, somebody that's sitting at the server, yes, they can see the password that you typed. Okay. So, but very quickly what happens is that password is usually not displayed unless you, intercept it. That password is immediately encrypted using a so-called hash algorithm. These hash algorithms are one way. So once I encrypt the number, like your plain password, and it becomes a hashed version, it's hard to reverse it, meaning then I can show you what the hash would look like. You cannot then reverse engineer, guess what my password was. So you depend on that, okay? So therefore, then what the server stores is not your raw password. The server stores your hash password. After that, even the DBA, nobody can find out. Then every time you log in, this is what happens. You type in your password or what should be your password. They do the same thing. The server takes your password, hashes it, compares with the hashed version that it stores, and takes it or rejects it, okay? That's all. So obviously the right person would know the right password. Then if somebody's trying to play with your password, they're guessing it. And then they give you 2 or 3 incorrect guesses. And afterwards, they think that somebody's trying to hack you, and then they stop you from logging on. Okay, this is cool. You already understood the whole hashing part. There's also something called salting your password. So salting is a different concept, but it's actually better than what I told you. So supposing Google picks for you a 16-character sequence, which is already pretty good. It's hardly, unbeatable. Nobody can guess what it is. But these days, there are machines that run 24/7. They don't guess words like ice cream or sweetheart. They basically look through random letter number combinations because they know that that's what the world is using. So if by chance your random number combination comes in, they can actually log in, right? That's very bad. So then on the other side, on the server side, what they do is as soon as you accept as soon as you type in some new cool password, they will not take your password and hash it. Instead, they'll add even more random letters and numbers, with 20 more random letters and numbers, and make it an even longer password. hash that and store it. So then that becomes much, 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 much harder to guess, right? That is exactly what salting means. And obviously they're going to store that extra salt characters that they added with your name because they already know who you are, right? In a database, in a private database. So when you type in your password, they know who your username is, obviously. They'll go to their database, look up that extra salt characters, add it to your password, hash it, compare with the big salted hash that they store. Makes sense? So servers try to protect you by making your password even longer, but you don't need to know, you don't need to care. Okay, I want to come back to trust. Okay, so trust is broken, when somebody basically does something that you don't want. Compliance is basically the rule of law, which basically says, say in the US, businesses should hold on to their tax information for 20 years at least, because we're going to ask for it. If you do business with the government, you have to follow all of these auditing principles. It's all called compliance, meaning obey like what I'm telling you. Laws. Governance is basically policies that companies have. So a drug company might say, we have a governance policy that says every single inventor when they file for a patent, should they give the patent information to an internal data science team, which will then publish the patents in an internal database that other scientists can access. So a massively large company like GlaxoSmithKline or something, which are all over the world, Pfizer, can then even within their company know what people have filed. Otherwise, people are trying to file the same patent, right? You have to have this thing called governance that says there's a policy that says we cannot hide our own patents. Anyway, that is just within a certain company, okay? That's what all this is, what's going to come up. All right, you got to care about these because in the coming years, basically everything that I told you previously might all be automated, okay? All the JSON is pretty obvious. The GeoJSON is obvious, the SQL is obvious, machine learning, what. But in the end, it might come down to your life and my life being run because of these things, or ruined because of these things. It's a big deal. Privacy was considered so important back in the 1970s. There was something called Fair Information Practices. I think it's FIP rules said this: data that companies collect, they have to be open with you. They need to tell you, that they're collecting data. They have to disclose exactly what data they collect from you. They should tell you what exactly they're doing with your data. Should not do other things with your data. So that is the secondary usage. Also, if you find that there's a mistake in the data they have on you, you should be able to tell them, fix it, and they should fix it. And finally, above all, they need to store your data safely so nobody can run away with it, in which case all this is useless. Back then they had it okay, but many companies didn't know or care about this. And now we have modern versions of these. So, Amazon and Alibaba, they collect so many things, right? They know more than 100 columns about you. That's too much. And so then if somebody takes all the data, they basically know your whole life history. So data is not private at all. Your data you have in your piece of paper in your hand, you can keep it private, keep it in your pocket forever. But because we do online stuff, somebody else is going to not be careful, then your privacy is gone, okay? Okay, so this is the whole notion of third-party cookie tracking. Anytime you go to any site, there's a whole cookie that the site stores on your machine with your permission. Accept all cookies, that's what you do. And then those cookies start to store all your browsing information and also send your browsing information to, again, the companies that you're browsing, like a shoe store, bookstore. And they can then take the data and sell it to some other store. A shoe store can sell your data to a sock store. The next time you go browsing for socks, they apparently know what shoes you bought. Then they'll actually give you the socks that matches those shoes. It's very creepy, okay? But that is the notion of this website tracking. It means anything you're buying from one site is not private to that site at all, okay? Like you buy guns and they might sell you bullets, stuff like that is weird. Your data is the new oil. And then, believe it or not, your medical data, this is legal in the US, is not owned by you at all. If you go have a blood test done, the blood test numbers, which is your body, your numbers, they're not your numbers. They're actually the hospital numbers. Yeah, right. So Google has a whole thing called Flock, that I can tell you at the very end. Yeah. Yes and no. Yeah, they literally block the notion of a so-called third-party cookie, but they replace that with an aggregation called a Flock, FLOC, okay? Like a federation of cookies, federation of similar consumers. So they still track you, but now it's parallel distributed tracking, which they claim is better than unique tracking. It probably is. Okay, here, the hospital that owns your data, without telling you, can actually sell your data. So what I told you earlier, right? It's actually legal for the US to do that. And that's amazing. So many states are trying to change that. And then, yeah, that doesn't work at all. The whole DNT does not work. You can check it on, but the website on the other side 100% ignores it. So that's basically just a misleading assurance, okay? Tor, I have like Tor right here. or Brave incognito. All right, so surveillance is all about loss of privacy, right? When you go on the streets, you absolutely are being tracked 100%. So China already has this database where all the 1.4 billion citizens, right? They can do facial recognition on them, 90% accuracy. It's just amazing. Even now, people wear masks, so that it's been fixed so that if you wear a mask, they can use just the upper part of your face to still track you. And it's very interesting, right? You can go in and out of the border. They know exactly where you went when you came back. Ultimate, surveillance state, right? So, no comments, but obviously that's what they do. But with China, we talked about this before. They go to Xinjiang, which is on the western part of China, and then they track the Muslim-looking people, the Uyghurs that live there, because they don't look like Chinese. And then they harass them because the machine learning, makes it possible. And so that is an extreme form of, using technology to do all of that. But the government needs to be careful, not to have terrorists run around. Here in the shop, a camera is deployed from the top. So what it's doing is analyzing not the face, but what behavior. She's trying to spin the bottle, look around, and look, her hand is going near the handbag. She's probably a thief. That is exactly what it is. No, maybe. But look at this. See, people are doing their things right, and then the camera just tags people that they're suspicious or not. And that's weird. Okay, looking is okay. Not very suspicious. Just, yeah, exactly. You really cannot get away. You just have to stay home, okay? In 1984, you couldn't even do that, the book, because the TV watched you. Okay, see, look, so that guy, right? No, shoplifting. Alexa, for, just basically machine learning purposes. Once in a while, they take 3% of the population of Alexa users, and they take your conversation, thankfully take your name out, and send it to third-party auditors that want to make sure that Alexa is running properly. So in that sense, you're doing something weird, like, you should kill the president. Somebody's actually going to hear that. And if they did not think that you were just joking, they might think it is serious and actually report you. So stuff like that has been done, by the way. Meaning, even though it is not trackable, you can use many data points to actually track Alexa voices back to actually people that said it. That is very creepy. So my answer to, when I said stay home, is our own devices, like, OK Home and Siri and Alexa are the ones that are tracking us, unfortunately. So you don't need the government to come and actually track you. In the meanwhile, in Japan, they have that thing that they're trying. Okay, so surveillance, privacy, right? Your search data, I just now told you, when you do the third-party cookie stuff, one site, second site, third site, whatever, it doesn't matter. But when somebody, so-called ad aggregators, aggregate your browsing data across many dozen sites over 5 years, they know so much about exactly what you buy, exactly what you like. That is what all this, okay? And so companies like Facebook and Google help them, because companies like Facebook and Google are the ones, that know so much about you. Facebook knows what pages you like. Google knows, again, what you search for. Amazon knows what you buy. And so if you put all that together, you form these crazy profiles about people, which is scary because you connect the dots. And then likewise, you go to a mall, Big Brother at the mall. So this is the US, okay? There are cameras everywhere, like that. And thankfully, they are trying to find out what is happening. What retailers do is in any store, this could be Abercrombie, I don't know, any store at all. Forever 21. So then you're browsing, you're walking by a bunch of jean jackets, and all of a sudden a coupon for jean jackets pops up on your phone, but not on the next person's phone, because they actually know who you are. That Prism is actually very scary. Good you're putting up all that, right? They know who you are, so they can hyper target ads for you, because the Wi-Fi knows that you walk by, and so Bluetooth is probably sending you stuff, right? It's very interesting. So you can accept the coupon or not. Therefore, malls use this technology. And then public security. So these are the publicly available cameras. This was a project that somebody did, okay, in New York City. They said, what if you collect all the information from all the cameras? Can you actually identify people? And the answer is yes, okay. So the guy that wrote this for New York Times built the system, homegrown, for just a few $100s, okay? And then you can know who actually people are that are walking by. So you're not anonymous publicly. $100, he puts it together. And then he did nothing illegal. These are all publicly available platforms, right? So like that person, eventually you would know that he's a professor at NYU. That's how many cameras there are, by the way. Holy crap, just within New York City. These cameras are all outside. I'll tell you about Go in just a minute, okay? Sorry. Yes, so no, it does something a little different. Yeah, look at that. So, you can then aggregate that with other things and do some comparisons, and, lo and behold, exactly what the person is. Just publicly identify people. Holy crap. At Hollywood and Vine, right here in LA, there's a camera that points down. Every time a car goes by, that's what the camera looks like. It takes a picture of your license plate and then does OCR, and knows what the numbers and digits are, and puts it in a database with a timestamp. That's all. But there are many cameras just like that all over Los Angeles. And then all that a police department has to do to see what's succeeded with this 3LKY619 license plate is they don't need to follow me, because I'll know they're following me, or be plainclothes. They can go to all these camera installers and buy legally their databases and type in 3LKY619 and then watch me on a map go all over Los Angeles. Wow, why is he going over there, that warehouse? What's happening? Oh, they're selling illegal drugs. What's he doing there? It's crazy, right? It's damn creepy. And so again, it is not illegal for those cameras to collect traffic data. And we're trying to actually stop that. Oops, that's where I went there. So, it's very weird. Android phones do this.
We know that Google is tracking us. We agree to it when we set up our phones. So we wanted to figure out what exactly Google is learning about us throughout the day. So here's what we're going to do. We have two identical phones. The only difference between these two phones is this one is in airplane mode. Both of the phones lack a SIM card, and they haven't been set up to access any Wi-Fi networks. So for all intents and purposes, these phones have no connection to a data network. We're going to keep them with us throughout the day. And while I travel around DC, we're going to figure out just what Google is finding out about me.
Our first stop, Sim's Convenience Store, just outside of Fox Bureau, for a quick coffee. From there, we took a walk to the Capitol and took a quick walk around the Senate office buildings, and then decided to hop in a car and head around town. Hello. We're going to the Children's Hospital, please? To run our test, we had to do more than walk the block, so we took a tour around our nation's town. It was a 14-mile journey that lasted Wi-Fi connection and not any cellular data service. It assumed that Google wouldn't even be able to collect data on me. Business model is simple. Collect data on its users and then use that data to sell targeted ads. It's a business model called surveillance capitalism.
Yeah, Google that to be so scared.
Even when your phones aren't connected. So we're back here at our Fox Bureau in DC, and we've got both of our phones exactly how we left with them. The only difference, really, I snapped a couple of bad selfies at the National Cathedral. But otherwise, they have stayed in my pocket for the entire day. So let's find out what they know. This is our man-in-the-middle device. It's basically a Wi-Fi network that these phones are going to connect to once we turn their Wi-Fi on. It's going to pass data through it on the way to Google and throughout the day.
Okay, so watch it.
With 100 locations, 130 activities
Actually, wait.
today.
This is crazy. Look at the data.
The phone that wasn't on airplane mode registered more than 100 locations, 130 activities, and even 152 barometric readings. As soon as it hooked up to our Wi-Fi, it transmitted 300 kilobytes of data straight to Google. The phone even logged our exact locations, tracking us all around town, the Capitol, the hospital, the school, and the cathedral. Now, you may notice what's missing here is the exact route that we took, but it got that data too. It knows when I got out of the car. The metadata has a time log down to the very second, tracking everything when they think that you're walking, riding.
That's JSON for you.
Okay, so you're thinking, this isn't a big deal. I'll just put my phone in airplane mode. Yeah, we thought of that too. This is the other phone that we had with us that no SIM card also remained in airplane mode the entire time. Let's see what kind of data it captured. The phone with airplane mode activated actually logged more locations.
That's crazy.
Privacy for nothing.
So, every year Google actually mails you like a map of all the places you've been. I look at that and I go, oh, I forgot I went to DC last year. It reminds you where you went, right? It is so damn creepy. Yeah, right. Yeah, I actually read about that. Exactly. Yeah, that's ultimately the bottom line. So you might need to kill the GPS data, okay? Maybe there's some libraries that you can get that can scramble the numbers. Yeah, it's basically a chip that is hard-coded, in the circuit board. It's constantly doing its thing. So we need some libraries to anonymize us. Okay, I want to move on though, okay? That is a very interesting, creepy deal. And so therefore, what people think of as the word privacy, maybe there's a real world privacy, there's a digital privacy, and maybe there are two different things. Meaning we cannot have the same expectation in the digital world as we have in the real world. So it could actually come down to that. Meaning we're actually given up, a version of what used to be called private. Like I said, if you want to be private, be a hermit all over your life, just don't go anywhere. Okay, so this is all like utopia, dystopia. In a good sense, these are wonderful because, you know, your body, your face can be any ID. I don't need my credit card. I don't need my keys. I don't need anything, right? I don't even need passwords. My face should be enough. But the bad part is, you know, this. In China a few years ago, there was a bus on the side of which there was a famous businesswoman's, you know, poster, like a big, you know, graphic. And the bus just goes by, and the traffic camera thinks that she's jaywalking and takes a picture of her, and then puts it up on a national, you know, like a big LED display up there, and then publicly shames her because they know who you are, they recognize you. Except it was a joke, right? Because she was not even real, just a picture on the side of a bus. That is where the ML basically fails in, like, you know, yucky ways. Yeah, flip phones, you know, could happen. It was highly embarrassing for the government, but, you know, hey, people had a laugh. Okay, so security breaches, right? So again, this like highly weird. Just search the word data breach, okay? Life logs, you know, like every single day, right? I mean, this is like recent stuff. All pretty recent. 16 hours, 8 hours ago. DigitalOcean is a huge cloud, you know, backend, by the way. Many people run the business on DigitalOcean. So who knows what was hacked? Maybe your credit card. There's even sites like databreachtoday.com. You know, it's so unfortunate, you know, that there's sites like that. Like, look at that, databreachtoday.com. Every single day something happens, you need a site for that? Wow. Okay. Last week, Facebook actually lost about 500 million people's email addresses and a few other things, okay? It's just weird. So it's all two things, your value, like money, identity, who you are, what you're worth. That's what they're trying to steal. These days, cameras, cheap cameras you buy on the web might have an older Linux distribution that might not be patched. So someone can turn your camera on while you're away and actually, or while you're not looking, and spy on you. That's what this is. So the IoT devices take this to a new level. If your pacemaker can be hacked, somebody can kill you by increasing your heartbeat, okay? If your garage door can be opened, somebody in the middle of the, you know, night can sneak in. If you're on and on, right? If your nuclear power plant can be hacked, it can blow your city up, seriously. So the hardware, real world, makes all this even more serious. So we need to take it much, much, much more seriously. You have a cam to, you know, watch your kid while you're away, but somebody else is looking at your kid, stuff like that. Yeah, mixed thoughts on that. I think that's more hype than reality, but, you know, someday. Okay, so, you know, this remaining time, I want to time it, okay? Ethics is, again, we've talked about ethics, all right? This is already done, so we can skip it. Unethical use of things like AI. So this is the one where I showed you the movie where, you know, it appears like these drones are being launched. And they literally go and target people. But it's too early to launch crap like that because, you know, the AI is not ready yet. So what if there's a mobile soldier, an actual robot that has a gun? This is horrible. Automated warfare. But the ML is completely so easily fooled. So what are you going to do? But it's too early. See, so if you stand there, you would die. Okay, so it's not a joke at all. It's not GTA 5. It's real. So we should not even be doing all this. They should be lost. Don't even make it. Don't even think about it. Basically, we're not ready yet. So then I talked about the racial stuff. You know, where most of the faces that are used for facial recognition are white, they're male. So if you're black, you're female, then you have a double strike against you. So thankfully, there's more tech that can come and help you. So IBM, for example, made like a diversity in faces data set. Then they publicly donate the data set to ML researchers. So at least when you train your machine learning network, use like a fair, you know, unbiased data set so that you're going to get good training. So that's what this is about. You can read, okay? Otherwise, you know, it harasses, like, you know, black people unfairly. In some cases, I think some NBA, you know, player was actually called a monkey. That's horrible, right? I mean, that's as racist as you can ever get. And then they points their fingers at each other. Well, I didn't do it. You know, ML did it. No, ML didn't do it. The data did it. You know, I mean, what the hell? Somebody did it. So in the meanwhile, you know, real people are getting harassed. So that's yucky. And then we talked a lot about fake video. So I can absolutely, you know, skip this part. But it's all about ethics. Okay, is it ethical to take your, you know, face and put it in porn? Absolutely not. But that's exactly what is happening. And then, so the whole, this is actually fascinating. I'll quickly tell you. You can read about it. You can I'll fix it. You can modify the loss function. Okay, this is actually code technical stuff you can do. The loss function is a calculation that calculates what is the difference between the predicted error and, you know, between the actual output and the predicted output. That's the error. If you change the formula, you can actually change the way the classification happens. Wow. So we should definitely, you know, be doing that. And then this notion of explainability, interpretability. This is when people say, for security reasons, we need to know what the network actually does. Explain to me. So we call this now XAI, because we don't know what those layers are doing. I told you. So there's a new branch of AI that talks about explainability. So at least we'll know why it's screwing up, and maybe you can hopefully fix the layers. That's what this is, okay? But XAI is still more like a hype technology. When you see this, is very cool, by the way. This is called a Gartner hype cycle. What this is every new technology starts to get hype more and more and more and more and more hype. Eventually crosses the hype. And after that, if it is actual hype, it'll die. But if it is a really useful technology, it'll go on to live forever. Okay, so many things are over here. Oh my God, that's a very complicated answer. I would say a little bit of everybody. Oh my God. I would definitely say that the ML, data set is horrible, because it misidentified somebody. And also maybe the algorithm itself is faulty, But how can that be? It's a network. Maybe the person that designed the architecture for the network, they should have picked a different network. It is hard to pinpoint, which is why we should do it before it happens. When the self-driving car kills people, it's the exact same thing. Who you're going to blame? They'll all blame each other. Yep. When nobody's accountable, right? What can you do? Okay, so then that is all it is. The notion of explorable. There's some help, I guess, from technology itself. These days, there's some tools where you can look in these layers, and then there's a scene in front of it. You can literally know what the layer is focusing on. Suppose you want the layer to focus on, here's the bad guy. Suppose the layer is looking at a coffee cup. That's a problem, you can fix it. So that is neat that you can visualize actually what the layers are doing. Okay, that's what this is. But there's still no actual intelligence underneath. So I'm still pretty skeptical. At least you can know that it's looking at the wrong thing. So I want to move on. Trust is very simple. Again, you have individuals, you and me, and we entrust so much data to organizations, even governments, even nonprofits actually. But they know they're responsibly using our data. And if they are not, once it's gone, it's very hard to get it back. So the other side, the businesses, need to be transparent. They have to exactly, tell us what they're doing with it. And then they need to use our data for good purposes. And if they screw up, they need to own up to us. Many companies, when they have a data breach, they won't tell you for 2 or 3 days, okay? It's actually too late when the bad guy has maxed out a credit card. It should be instantaneous, but they don't want to own up to it. So that should all change. So trust is a very interesting idea. Again, once trust is broken, it's really, really, really hard to get it back. In a relationship, okay, if somebody cheats, okay, the other person is basically damaged forever at some point. You can make up all you want. It's not the same, right? It's the exact same thing. Trust matters like hell. So therefore, if you're a company that is actually going to, want other people to trust you, never screw up. Yes, that is true. It's funny, but Chipotle, oh my God. I actually eat there, believe it or not, but yeah, I screwed up big time. Okay, so compliance is, again, just a legal thing, okay? So what laws can you pass? In Europe, they actually made GDPR. Okay, so as of, 3 years ago, one set of guidelines for everybody, okay? It means if you are in any one of those 29 European countries, you have all of these rights. There's one called the right to be forgotten. It is so amazing. You can tell them, delete all my search history. They will do it. They need to get consent for every damn thing, which is why these new cookie pop-ups all over the place. What cookies can I store about you? In the past, they did not need your consent. Now you have to actually say yes. Otherwise, they're in trouble. They need to disclose exactly what they store about you. Penalties for screwing up, which is great. Money talks, okay? It's all about money. This is great. So you can tell them, delete my location information you have for the past 6 months or 10 years. All the terms I ever searched for. Google will have to delete it, okay? In the US, they'll laugh at you. Amazing. So GDPR is way ahead of the US. US has some laws as well, but then it's all over the place, okay? So you can just compare. It's state by state, different states to different. Yeah, we have something called CCPA, okay? So we're actually one of the best, but we're still not as good as GDPR. Good. Okay, so that is all I wanted to say about compliance. Governance is all about how do you govern the data that you collect and use? How long should you keep it? How do you audit it? How can you tell if it's bad data? And what will happen if it's bad data? How do you fix it? Say you find your data to be biased. How do you unbias it? You need rules, otherwise nobody would do it. So that is all called governance, okay? So governance, and then the people that actually do the governance, they're called curators. So this is more like the tech team, it's more like the management team. And curators are actually what are also called stewards. So stewards are basically owners of data. Initially, the curation team owns the data, but eventually the whole company, say again, drug company, you own the data. You need ownership of your data. And data, if possible, the team should make it so that it's only in one place. It's almost like a primary key, okay, or a function call, everybody calls function definition. Master data management. Master data means I don't have replication issues. Like, don't replicate my data. As soon as you replicate it, it's going to go out of sync. Somebody's going to change this, but not change that. So make everybody point to one source of truth. That philosophy is called master data management. Okay. It's 5 minutes. You can, by the way, get into data science by even doing all that. See that? So interesting. Okay. You don't have to be very technical, but look at what you get. So it's a soft path to actually getting into data science. Again, you can Google, MDM curation, all the things that I mentioned, MDM, like see knowledge management, data curation jobs, and then MDM governance. Okay, just do this really fast. Governance. These are more legal, and then more business oriented rather than data oriented, but still those things exist like right there. So just click on all this and see what they want. Okay, like neat stuff. Okay. By the way, you don't need to know a little bit of things like SQL and stuff. Okay. Wow, look at all the ways in which you can describe them. It's crazy. All right. So then that is all it is, because eventually you want the team, the governance team, to take the data that the company already has and make it available so others can profit. So then what about the policies, procedures, rules, guidelines? Together, these are called governance, okay? So the company has to agree to make the governance layer, the management layer, and then the curation team can actually do the real work. So the curation team's job is to take some raw data and make them into curated, like a museum curator. Curation means publicly show something and make it valuable so that people can appreciate it. So you can take the data that was basically hiding and now make it valuable by curating it. Okay, that's all this is. So curation means must be visible, must be accessible, must be interoperable, all this. Don't worry about all the details, okay? Okay, so you need a curation infrastructure. It means you need a governance infrastructure. So what is curation? The main reason is you want to benefit, you want to get extra value from the curated data. Like why would you not do it? It's a form of data mining, okay? But you're not mining it, you're just putting it out there. Okay, so that's what all of this is. Okay, so what is curation? It's like management of data, and then includes discovery, retrieval, maintain quality, value, add value, provide for reuse. Again, in big companies, you need to reuse data you already have. Otherwise, somebody's reinventing the wheel. Cool. So then what is governance? It is the management layer, okay? So you need a governance team to basically authorize and empower the curation team. Otherwise, the rest of the company will laugh at the curation team. If you go and tell somebody, give me your 10 years worth of data, they'll basically say, who the F are you? Like, who gave you permission to come and ask me? Well, these people did. So that's exactly what governance is, okay? Provenance is just simply timestamping data with all of the paths that the data ever took so that you can trace it all the way back to the start. That's what all this is, okay? It means you want to track, especially scientific data, okay? Like where did the COVID-19 data that the whole world uses, where did that come from? If your source was faulty, somebody's making it up, nobody should use it. That is the notion of provenance, okay? You can think of data as like a little boat that is floating down the river. So every stage in the river, every few days, you want to timestamp it so you know where it went. So that way everybody knows how you trace it all the way back to the source. Okay, so it's again about trust or lack of trust. If I don't trust the source, I should never be using it. I should not make public policy with it. Scientific data, it is horrible if you don't know where it came from. Somebody could have made the whole data up about a COVID vaccine. They spend $1 billion making it. It's completely useless. So crap like that, okay? All right, so then in the scientific field, I'm almost done. I'm gonna tell the then recording engineer that I'm gonna go for maybe a few more minutes, 3 or 4 more minutes if you don't mind. Okay, so this paper just talks about in the scientific field, specifically, why is data governance, why is lineage such a big deal? Because again, because your whole hypothesis, your whole law that you drive is going to be wrong, okay? So if you screw up on lineage, you're going to have life or death consequences. That's the idea. Okay. So again, with coronavirus, you have these fake drugs. Thank you so much. Thank you, sir. Yeah, I appreciate it. So like that. See, this is bad, okay? It's literally with COVID. Somebody goes off on a tangent and does something. The scientists say, oops, sorry, bad data. Oh my God, I'm glad you told me now, Okay, so just a few more slides. So MDM is master data management. So, going with all of this is if you want to do good curation, you want to do good governance, one thing you want to do is protect your data. One way you want to protect your data is to keep exactly just one copy is not even a copy, just a single point. Everybody points to it, okay? Okay, so then that is one reason, make it consistent. There's nobody else, it's just only one. Okay, cool. Because otherwise you get errors, disk space, traffic. So MDM is like a thing that companies do, if possible. It's a good idea. This site's wonderful, by the way, dataqualitypro.com. There were lots and lots of data management articles. So this tells you what MDM is, okay? Okay, so you see it's right there. This all goes back to, your beginnings of this whole course, where you talk about business, knowledge and value and how you model data. It's all related to that. Just keep one copy of data. So therefore, governance and security, privacy, they're like a triangle. Security breaches, unfortunately, are way too common. Yahoo lost like 500 million actual emails, okay? But people did like pretty shady things, and now the whole world knows who they are. It's like horrible. And then governance is about policies, and you should. So if you don't have good governance, you're going to have security breach, and people are probably going to break privacy. So privacy, they're all pretty costly, because if these happen, lawsuits is really what it's all about. Therefore, you need good governance. And then how do you explain governance to your management? You need to tell them our business needs to be, secure with people's data, need to be good with privacy. Why? The boss wants to know why. Because you're minimizing your risk to your business. Your business could go out of business. Oh, okay. In other words, CEOs and upper level managers love minimizing risk. They hate risk. Risk means you don't know what's going to go on. So explain to them in terms of risk. It is risky if you don't have curation. It is risky if you don't do MDM. It is risky if you don't do governance. Oh, okay, how many $1 million do you need? Go ahead and do it. That is exactly how you sell it to them. You put it in terms of risk, okay? It's risky not to do it. Okay, so then this tells you the complexities of machine learning. So here's your homework. But what they're telling you is, once in a while, you have to collect new training data and actually retrain your network, because all your weights are now no longer applicable because society changed, so data changed. We shouldn't use this network forever and ever, okay? That's what this tells you, shit like that. Because the actual ML engineer, the data scientist, they don't care, right? But somebody else has to care and say, hey, it's time to retrain. That's what they're saying. It should be somebody's job to point that out. Okay. So security and privacy sound pretty similar, right? But you need security before you can have privacy. So security is actually a technical thing, and you can 100% prevent it if you can. And then privacy is more like a legal framework, okay? Cool, so you know that. You should first protect it, and then you can enforce privacy on top of that. Wow. Okay, so it's 8:22, we're already out of time. But I mentioned, right, what government surveillance is. China does surveillance. China also has this very interesting idea called social credit, right? Where you start off at a baseline, you do good things, you help older people cross the street or, pick up some trash. Your score goes up. You do horrible things, your score goes down. And so that's a very interesting form of keeping, control over your population. And how does it become real? Because one day when you go admit your child in a school, the school might say your score is too low, the kid does not get in the school. So basically they make people comply, but it's all data, right? They track every damn thing that you do. So again, legalities, ethics of fake video, fake audio, fake image, fake text, all of these. This notion of information, yeah, exactly, like Black Mirror, absolutely. So it's like warfare, and information is what it is. I told you, it is the future of information warfare. It's all about disinformation. It's all about data, okay? And then data. It's shocking how much it's all about data. Okay, so, so we need to watch out for that. And then I think I showed this to you. Yeah, sure. And actually I didn't. Yeah, very interesting, this notion of, fake video, all of all this fake news. Okay, so a little talk there. This is my friend Laurent Lay. Good old Professor Lay. Let's look at that. Lay. Okay. And different talk. This is the one I told you. Good. Okay, there's lots and lots of expert data. And then just with COVID-19, all these things apply, everything that I told you. Privacy applies for COVID-19. By the way, people should never know you got the test, okay? Definitely not the test result. And then provenance, where did my death rate data come from? Disinformation happened too many times about vaccines, right? Discrimination, this also, sadly, privileged communities get oxygen, they get vaccination, others don't. Data breach. This also happened, For example, even like virus DNA codes have been leaked. So crazy things happen if you look around. So that is basically the whole GPS, etc. Okay. So then, I didn't tell you too much technically, but we thought that it was extremely important. So to wrap it all up, you guys have DMML tools. There's so many tools. I'll tell you the trend, just in the interest of time. I don't want to keep the den operator. The trend is there's less and less coding, more and more cloud and self-service, in the sense more and more things like Basit, are predictable labs, predictive labs. In other words, data flow. So why so many APIs in Python? Because they're all competing with each other. Sure. And now it's down to just PyTorch, versus TensorFlow versus Keras. Visualization, what a correlate is? It's a map where you have like a value for every single point on the map. The alternate is to just simply have like a table, maybe county names or city names and numbers, which is totally meaningless, okay? So it's more sense on a map. Good. So again, there's massive problems that are happening as we speak with all of these. So we mentioned some of them. It definitely is the real world. So I wanted to put up this very cool graphic called a data map, right? It's like a subway map. You can, expand it. After this course, just pick something, maybe pick like vectors versus matrices and go and teach yourself. Next day, pick this one. What is the Pearson correlation coefficient? This pure statistics, by the way. So then learn, okay? So everything that we ever did, all data science, all machine learning is all over here. It's like a master list of all the cool topics. Maybe you like this part of the city best, then focus on this. So it's really like a handy checklist of all the cool things you can learn and do, okay? So have fun with that. And look at this. So then it turns out it's all about data. Cool. And that's exactly how I want to end this class. Data rocks, data rules. So we're officially done, okay? Good luck. Have fun. Yeah, the map was wonderful, I agree. I used to have that map as a desktop actually for a long time. I look at it. Yeah, data, yeah, exactly. So from here on, like where do we go? You can do your homework, submit it. So have fun with the cat dog deal. Thank you, James. Then we'll meet for the final. The final hopefully will be extremely straightforward, so don't worry about it, okay? I'm gonna make it as easy as possible. I think all of us have gone through enough crap. Yeah, absolutely, lots of samples, probably 2 or 3 samples, I'll put it up. So don't fret about the exam at all. Hopefully get good grades. Thank you, guys. Cool, wow.
Could you post the link to your 571? I lost the link.
The which one?
Your 571 class?
The Py. Sorry, what?
The class site for your 571.
Oh, 571. Oh, I'm so sorry. I didn't hear the 571 part. I'm sorry.
No problem.
Yeah, okay. 571 and then S21, so I'll put that up. You can also have fun. I'm teaching the third one is about computer graphics, okay? So that's literally what we talked about today. So if you want to do graphics, then that is the graphics one. And I talk a lot about data and graphics, by the way. I talk a lot about ML and graphics. Yeah.
I tried Googling for it, but I couldn't find it.
Oh, I see. Yeah, sure. It's all up here. All right. So thank you, guys. It was fun for me as well. So we'll see you online afterwards, okay?
Thank you.
Bye, everybody. Okay. Welcome, Karishma, Nathan, Jiha. Dan can cut me off anytime. Wrong, Harsh, Aryaman, Kevin, Kaiway, Odaya, Sonia, wrong, Grima, Tata, Sweerag, Isha. Cool. Stop share. Malaki. To have you in all my classes, Malaki. Harshit. Bye. Vaibhav, Yuchi. Cool. Cheers. Yes. Leave. Okay. Derek, goodbye to you as well. I'm glad I didn't miss you.